Now, all right, guys, we are live. This is the fifth and final help session for PES. Thank you for coming. There's a lot of people here, and we actually have a lot of questions already lined up. Who booted Bo? You're in there. Wait, sorry. So we did have Bo here to help as well. Somehow he got booted. Now he's back, I think.
Can you hear me?
So he'll be out. Yes, I can hear you.
Hey,
so
everyone.
Bo's here as well to help. If you haven't done this before, you can access either the YouTube chat and put your comments there, or you can join the Hangouts. However, the Hangouts is pretty full, so you might just have to stick to the comments this session. That's the start. So if you've got any questions, keep them flowing. We are expecting that you participate. So we want some feedback from you while we go to see if you can answer certain questions. So we'll give you time to answer them when we go. So the first question that was raised is this question here. So we have, what is the output of the following C program? So we have our include as normal, we have a function prototype, and below we have our function, and then we have main. Now, the tricky part of this question was the fact that some of the pointers point to places that they shouldn't. However, as we saw in previous live streams, this is okay as long as we don't access what is in them. So I can point a pointer at anything, and I can grab the address of any pointer anywhere, even if it's an illegal spot. As long as I don't access what is in there, it will not segfault or cause a problem to my program. So we're going to have a quick look through this program. So to start, what we're going to do is we have two functions, so we separate them out. If you're in an exam, just quickly draw a box. In an exam, you don't have to draw out everything neatly, but you should try and show you're working, just in case you make a little mistake. At least you can pick up marks. So we start with our array. Now, with our array, we've got to remember that this ARR by itself is an int star, okay? It's pointing to the start, the first position of the array, and we can't change where that points. Then we create x, which is an int, and it's got the value 0. We then call our function, okay? So the first thing you should draw when you call your function is these variables here, okay? So the first variable is int p, int star p. So our type is int star, meaning it can point at ints, and its variable name is p. And then we have n, which is an int, and then we have int star r. Now, how to fill these? We just look at the same positions in the function arguments. So the first parameter is int star p, so it takes the value of r. Now we know r holds the address to this first element. So what we can do is point this here. Now this is okay because this is an int star and it's pointing to an int. Remember, int star can point to an int star star can point to an int star, and so on. The next one is n. So we take the 4 and we put it in n, and then we take the address of x and we store it in r. So this here, we don't know the address, but we can assume the address. So here, we can point to it, and this is saying that we hold the address in here. Now, this is just a representation. There's no actual line pointing to this. It is holding the address. So for example, if this is address 10, then this actually, in real memory, is holding A10. Now, another thing to note for this question, and for any arrays or dynamically allocated arrays, these are all contiguous memory. So if this 1 is stored in A0, this 6 would be stored in A4, this 3 would be stored in A8, and this 5 would be stored in A12, guaranteed. Now, the reason that we jump by 4s is because it's an int. So it skips different addresses for each byte so that we can store the values there. If there's any questions about that, let me know. Okay, have I missed anything?
No, it seems pretty good.
Nope. All right, cool. So now we're here. So we now create another variable called int I, and it takes the value that P is pointing to. So this star says we are dereferencing P. So we follow the line once for the 1 star, and we grab the value 1. We then need to be really careful when we have things like this. So we have int I equals star P, comma, int star Q equals P. So Q is actually an int star. Okay, we're not dereferencing Q, we are declaring it. And it takes the value in P, so it's taking this value. Now, if we had the address, it would be A0, but we are using pointer notation, so we can just point it at A0. So anytime you're unsure, you can think, what address would this hold? And you can just make up some addresses here to see if you grab the right value if you ever want to double check. Now, given this, we also know this is legal because we know this is an int and this is an int star. And as we said before, an int star can point to an int. We take this 0 and we store it where R points to. So we're dereferencing R. Now this dereference is on the left-hand side, so we go there and store the value. So we follow this line and go here, and we store a 0 here. Now there's already a 0 here, so it's just a 0 again. Now, the next part is the tricky part. Well, the first time round is not too tricky, but let's break it open. So we have P equals Q plus N minus 1. So here we are doing some pointer arithmetic. So we have Q, which is a pointer. So it's pointing at some address. So I'm going to give it the address 0 because I know that this memory is contiguous, and I'm going to plus n minus 1. Now n is 3 minus 1. So we end up with 0 plus 2. So we have 2 here. Now, because this is an int star, this 2 is actually representing, yes?
Why n is 3? N is 4, right?
Yep, my mistake.
Pick up on that. No.
Yeah.
So we've actually got plus 3, sorry. So we're actually looking at this one. We know this because this is an int star, and we're saying 3 times 4. Okay? Because this is all dealing with ints. However, because this memory is contiguous, you can treat it as being 3 as well. It won't really make a difference because we know this is index 0, 1, 2, 3. Okay, so generally, if you want to do some arithmetic, I would just set your first address to be 0 and then move from there. Then we say P equals that address. So now we're saying P points to here. So P is actually pointing at the end of the array now. We then check, is P greater or equal to Q? So I can treat this as being, is 3 greater or equal to 0 if I wanted to? Or I could treat it as A12 is greater or equal to A0. Because this memory is contiguous. Yep.
Yeah, another way you can look at it as well, you could see where the arrows are, and you can just see if the arrow is further to the right as well. That's when you look at the diagram.
So you can see this is greater than this one here.
Yep.
Okay, that's a good point. So that is true. So now we can go into our loop. So we have star P is less than I. So star P is dereferencing P. So we have 5 is less than 1. I don't think so. So we skip over that. Okay, and then we're in a for loop, so we go back up. The next thing that happens is our minus minus P. Now, because it's an int pointer, it will go down by 4, but you can think of it as 1 because it is contiguous. Okay, so now it's pointing here. Now, from there, we now have, now I've lost where I'm at. So now we have star P is less than I. So is 3 less than 1? No. So we skip over that and we go back up. Now at this point, you should be able to work out what's happening. However, we'll continue on going. So we subtract 1 from P and we go to 6. So is 6 less than 1? No. So then we continue. We subtract 1. And so now they're both pointing at the same thing. We have this equation here. Is P greater or equal to Q? They are equal. They're both pointing at the same thing. So we continue. Now, is 1 less than 1? No. So we skip over that. So in this code here, this here never gets executed. It's a pointless bit of code.
Sneaky.
And this is what white box testing tests when we did that, if code actually gets executed or not. Then we go up and we still subtract 1 from P. Now, this is now pointing at 1 before this array. Now, obviously you can't have negative addresses. So this would be A0 minus 4. This wouldn't start at A0, it'd be something else. So if this was, let's say, A8, this would be A4. A4. Because we are not accessing what's inside there, it's not going to cause any problems. As soon as I dereference and try and access something or write something there, then it'll cause problems. But there is nothing wrong with pointing at somewhere illegal. So now we check, is P greater or equal to Q? No. Okay, because P is now less than Q. Okay, and we can see that, as Bo said.
Yeah. Yeah,
So
it's a good visual.
Now we exit this, and we return from our function. Now this function doesn't return anything. So what happens now all this is gone. Okay? What gets printed? Printed. So write in the chat what you think gets printed, so that I know you're listening.
Got a few zeros.
Cool. Cool. All right, so one of the questions that got asked on the YouTube chat, is working needed for full marks? I don't believe it is specified. However, I would highly recommend it, because if you make a single mistake, and these questions can get further complex, the lecturer can look through and see where you made the mistake. If you have no working and you just pick an answer at random, you're likely to get less marks than someone that had working. If you get the right answer, I can't see why you wouldn't lose marks, unless it says on the exam that you need to write working, which I believe from memory it doesn't.
Yeah.
But if it does say that you need to show working, then you need to show working.
Yeah.
Okay. All right, cool. Everyone knows it's 0. Does anyone have any problems with that question? We all good?
What a trick question.
What is the hardest question we are going to face in the exam? Well, that's a hard question. However, I think most people will struggle with writing code from scratch given a problem statement. I think that's going to challenge people, but everyone should have a go at it. Yeah. And even if you don't know how to solve the problem, you still should know how to do. There's no one here that shouldn't know how to do a hash include standard IO. .h. There's no one here that shouldn't know how to do an int main.
Yeah.
There's no one here that shouldn't know how to write a function prototype and write a function. You should know how to write return. Include as much information to show you understand the syntax and basic understanding, even if you can't solve the logic of the problem.
Yeah, when we're marking, we're looking to give you marks, you know? So if there's anything you can just give us that, you know, obviously it has to be still relevant, but, you know, even if you can't solve the whole problem, just doing a part of the problem. If you know how to do, you know, like a function, you know, just one function out of 3. If we ask you to do 3 functions, then just do the one function you know how to do, because then we can give you the marks for that function or for that piece of code.
Is this question going to come in? We can't tell you what questions are going to be on the exam. What we can tell you, however, let me get it up. We can tell you exactly what will be on the exam. So on LMS, there's a link called types of questions. It tells you exactly what types of questions will be on the exam. So this is what your front page of the exam will look like if you're doing CSE 1 PES. You'll have 15 minutes reading time and 120 minutes to write. The first type of questions are multiple choice. They're based off the lecture material, so make sure you have a quick read of the lecture material. They're all things that you should understand and know. Programs and code fragments. To get good practice with this, I would just do the quiz, the practice quizzes a lot of times, and try problems like we're covering right now. There is going to be a lot of these. Okay? Show the memory using box and pointer diagrams. Able to do this and should be able to do it fairly quickly. You need to pick up your speed when doing this. If you go back into week 12, lab 12, this is exactly how it will be written on the exam and the format that it will be in. It won't be as long as this one. This one's 11 parts. The one on the exam will be 6, 7, 8 steps. The question will look very similar to this. It won't be exactly the same. However, what I have done, I've given you a bunch of examples, C programs. that have that same format that will look similar to what's on the exam. If you can draw the box and pointer diagrams for all of these, you'd be fine.
Yep. And the box and pointer diagrams are not just useful for the section where you have to do the box and pointer diagrams. Like we showed before, you can also use them to help yourself do some working out. So you can kind of get through the mental gymnastics that you need to do to solve some of these problems.
And the box and pointer answers of how it should be written is here. It is a lot of diagrams, but you need to just draw them quickly. There's less steps than this one. This one's quite long, but it's still a lot of drawing. So build up your speed when doing them types of questions. Don't make sure you check the clock, because don't get stuck on this question. This question here, identifying errors. So this is probably one of the harder questions, but not worth as much. And this is for students that really want to show their skills. And you'll be given a bunch of errors and warnings from some code. You won't see the code. And you need to explain what the error is and then ways that it could be fixed. And there may be multiple ways, as we discussed with this one last week or last help session. So this type of question is probably going to be one of the harder ones. But don't get stuck on it. Focus on the other ones first. Flow diagram. Given a problem description, you should be able to draw a flow diagram from it. Okay. And if you look through the very early labs, we did this multiple times. And then the big one is write a complete program. So when we say a complete program, you will not be given steps. You'll be given a problem statement, like in lab 10, I think it was. So I should really open that in another window. So in lab 10, there's no lab 11.
Whoops.
So this is the kind of thing that you'll see for the write a problem. It won't be this long because we had a whole lab. In here, you've only got an exam. So imagine it'd probably be something like maybe half that or maybe a little bit less. So given this, you should be able to write some code. Don't worry about the debugging stuff, but you should be able to look at something like this and write some code for it. Okay? And this is testing how well you can solve a problem using code, which is the most important thing that you should get out of this subject is solving problems, because even if you're not using code, this kind of thing applies to anything.
Yep.
Okay. So this is the kind of thing that you'll have to do for the final question. It will be a short little explanation. It will give you some clues. So for here, if it's not invalid, it's telling you there's if statements and so on. So know how to do that, know how to call a function. It is going to be shorter than this, but that's the kind of question. Now, if you are doing 5 CES, what happened to this? Oh, if you're doing 5 CES, so you're doing masters, then you actually have 150 minutes and you have an extra question. So given a program, a more complex program, and you need to describe what the program does overall, and then you need to identify what statements do. So there's going to be arrows pointing at certain statements in the code, and you need to describe what they do. Okay. Now it's not going to be something like a type hello world on the screen 3 times.
You should do that now. That'd be.
It's not going to be overly complex. It's probably let me have a. It's definitely going to have pointers in it. It may have arrays and it may have functions. It's not going to have anything like files or anything overly complex that you need to know certain functions for. So you're not expected to memorize functions. You are meant to know the basic string functions, so string copy, string compare, and string length. They're the only 3 functions that you really need to memorize, and printf, scanf, the basic ones.
We had a question from.
Yeah, we're still going through these questions. These questions got asked first.
No worries.
So we'll go through the question.
Yep.
Sent in early.
All right.
Okay, so I had a question about using shorthand notation for the full program. No, you need to write out the full printf. Don't use shorthand notation. It needs to be a compilable program. Okay. You can use shorthand notation in the box and pointer diagram and in the flow diagram as long as you put some reference there. So if you say I stands for int, that's fine. But no, in the actual code, you need to write it out like it is going to be compiled. So don't shorthand the code. All right, so let's quickly go through this question. So we have a bunch of inputs. This is a fairly quick one. We have a variable called stop. Now, generally, you're not going to have time to write all the box and pointers. So if you know there's no pointers there, I would just write stop and I'd write 0 next to it. If there's no pointers in the question, it's kind of pointless having the box and pointer diagrams unless you really want to. Then we have a variable called grade. Now we grab the 37. It's the first int, so grade is 37. Is grade less than 0 or grades greater than 100? Nope. So we go to the else statement. Is grade less than 50? Yes. So printf fail. This is a horrible question. Sorry, guys. Whoever asked this is not very... Okay.
You'll be fine, guys. Don't worry.
So now we get here, and we've got a do while loop. Now, not stop. We know that anything that is not 0 is true, and anything that is 0 is false. Stop is 0, so we're saying not 0. So not 0 equals 1. So while true, it's still true. Okay? If this said while 7 or 6, it's still true. It's not 0. So we go back up. We create the grade variable again.
No, if stop with 6 or 7. If stop with 6 or 7, then it would...
Oh, yeah. If it was while 6. I mean.
Oh, okay. Yes. Yeah. I got you.
All right. So now we go back up. We now grab the next value. So we've got 75. So we change this to 75. Then I'd go, no, that's not true. I can quickly go through that. I can go, no, it's not less than 50. Else if, is it great? So else, so it's pass. Okay, then I print a space. Then, now I'm just putting them there. You can just show the space. Has stop changed? No, so we continue. Go back up. Grade. Grabs 93. So close that, 93. Go down here. We know it's not between them. Else, is it less than 50? No. Is it greater than 90? Yes. Excellent. This is what everyone will get. This is what you should aim for. And then we print a space at the end. And then it's stop still hasn't changed. And then we get a -1. So we have -1 here. Is grade less than 0? Yes. It's an or statement. So either can be true. So remember, or is either true. Okay. And both true. To be true. Okay. So we grab stop and we change it to 1. So We don't do this else because we've already done something. So we come down here and we say while not 1. So not 1 is not true. So it's 0. So this ends. Okay? So we're saying while 0, so this ends. So the final answer would be fail, pass, excellent. Okay? Happy with that?
Yep.
Okay.
Excellent.
Excellent. Okay. This question I'm going to do a little bit differently. And I'm going to do it without box and pointer diagrams just for the explanation. And this goes back to the question up above anyway. So what I'm going to do is draw a big box of memory. I'm doing 8 by 8. Now, you shouldn't need to do this. I just want to explain this in terms of memory rather than... So remember, box and pointer is just the representation. So this... Bo's asking questions.
No. Someone said question 23 from lab 12, so I went and copied and pasted it. It's not indented though. So it went and got it.
I think we covered that in the first help session, so you might want to quickly have a look to see. So we have our addresses 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17. Wait, did I skip? Do I have enough boxes? Oh, it's because I started at 1. Should have started at 0. That's confusing the hell out of me.
Wait, I'm lost.
Yeah, because I didn't start at 0. So I got 17, 18, 19, 20, 24, 28.
Oh my god, man.
Yeah, I know. It's confusing. So, start from 0. That's what I would recommend. However, don't worry about that. So this is 25. This is 33. This is 41. This is 49. Yeah. This is 50, 52. This is 56. This is 57. This is 13. This is 21. This is 29. This is 37. This is 45. And this is 53. Okay, that should be enough. I should have started at 0, as the numbers don't line up by 4s, but that's okay. What we can do is we'll deal with that. So I first create this array of 5. So we find 5 ints in memory that are in order. So it has to be contiguous memory. So I'm just going to pick these. We don't actually pick them. The memory management unit will, but whoops, what happened there? So we've got 1 int there, 4 bytes, another int there, another 4 bytes, 1 int there, another 4 bytes, 1 int there, another 4 bytes, and 1 int there. We then create a num, and then we initialize it. So this first one has 2, second one has 11. So remember, it's this whole byte is 11. It'll be a lot of zeros if you convert it to binary, but we'll look at that later. 3 and 7. So then we have int num1. So let's make it this one. Actually, no, I'm not going to make it that one. Actually, I'll leave it there because I've already done that. So this is num, and this has a 1 in it. Okay, and it's them 4 bytes because it's an int. And then we create a pointer. Give me a red. And I'm going to put the pointer up here. So remember, the memory can be anywhere. And this pointer holds the first address of ARR. Remember, ARR name by itself is a pointer to the first memory address. So this will hold 17. Okay, so we've got address 17. Okay. We ignore the 18, 19, and 20 because this is the first address of this int. Now, Josh made a big mistake here.
Oh,
Let's just get rid of that. That shouldn't even be there. So we're just going to ignore that because that was a mistake. You can blame Josh.
yeah. Remember, you can't initialize, like you can't declare a variable inside the for loop. At least on
Well,
the
not
C.
only that, it's not the same
Yeah.
one again.
Yes. So we're just got an empty.
Yeah, that's fine. So we're just got an empty initializer.
Yeah.
So nothing happens in the initializer. Yep.
And you can do that, by the way. That's perfectly legal. You're allowed to do that. You're allowed to just have the for loop. You can have any part of it empty, as long as you have the semicolons.
Yep. And we covered that yesterday as well, if you look back. All right. So now we have P, which is an address. So P holds address 17. And we're saying it's less than the address of ARR5. Now, ARR5 is a shorthand way of writing star ARR plus 5. This is what it represents. And then we're adding the address symbol in front. So we're saying the address of ARR plus 5, dereferenced, and then we grab the address. Now, normally, this is bad practice because we are actually creating an offset and then grabbing the address. This isn't good practice. You shouldn't do it because it actually does dereference it. So you need to be careful. The optimizer will make sure that's safe, but we'll ignore that. Okay, so we've got ARR plus 5. So 17 plus 1 would be 21, plus another 1 would be 25, plus another 1 would be 29, plus another 1 will be 33, plus another 1 will be 37. Now, I'm counting up in fours because ARR is of type int star. Okay, ARR is type int star because it's a pointer to the first address. Okay, ARR itself by itself is an int star. This here is an int. Okay, because it's dereferenced it. We then grab the address of this spot, which is 37. Okay, so we grab the address because it has address here. So is address 17 less than address 37? Yes. Okay. Now, if I didn't draw this...
Matt, can
Yes?
you please explain this again with ARR
Yes.
5 and it's like how do you manage getting that star ARR plus 5 and all? Can you just explain it again?
So you know this is the same thing as this, right?
Why star?
Yeah.
Or just because it is a pointer itself?
Yeah, because ARR is a pointer. We do a pointer arithmetic, so we offset it by 5, and then we grab the value.
Yep.
So we are dereferencing the value which is
Does that make
stored in that memory address, right?
Yeah, so if I use ARR 5, what does it do? Oh, let's say ARR 2, what does it do?
It goes
grab
to the
5,
second location of the ARR, position second. So that is 5.
Third position. Third position.
Yeah, sorry.
It will go to the third position and it'll grab the 5. It doesn't grab the address, it grabs the 5. So
Yes.
that is the same thing as saying ARR plus 2, isn't it?
Yeah, makes sense.
Yeah.
Yep.
So we are doing the same thing here, ARR plus 5, and we grab the address of that spot. So we
That
get
location.
37.
Yeah, makes sense. Thanks.
Yeah. But in this instance, it looks a bit dodgy because it looks like you're grabbing the 5th value in the array, even though there's only, four positions.
Yeah, exactly.
But that's not actually happening though, because the compiler will notice that you're also getting the memory address simultaneously as you're accessing that element, and so it'll make it just get the memory address. It won't actually access the element. But that's a thing that you have to, you're worrying about the compiler doing that for you. If it didn't do that for you, it would result in a segmentation fault. So that's why Matt was saying it's bad practice.
It is bad practice, and yeah, you're better off using proper notation or saying P is less than or equal to ARR4.
Yeah.
Oh, okay.
Address of ARR4. So to improve this, I would say this. Okay? This is bad code. You can blame Josh. He wrote it. So I would write that. That's a lot better and a lot safer. So we have address 17 is less than address 37. Now, we don't need to draw all this to work that out. You can look at how Bo was saying, if we had 5 spots here, we had 2, 11, 5, 3, and 7, and P is pointing at this first one, and then this one's pointing at one after, so there's a ghost spot. We know that this, then this, okay, it's after it. So the address, the number, remember it goes up, is going to be greater. So you can look at it like that, and that's how I would look at it in an exam. I wouldn't be writing this massive table.
Yeah. So you know what? You know in the stuff when the 2 arrows are pointing at the same position in this case.
Why don't we use the length of the array? Yeah, so we could use the length of, so another person mentioned that we could use the length of the array. Yeah, that would be a suitable answer as well. Sometimes we won't know the length of the array. Here we do, so we could easily use it. So we could do something. No, we're not actually using an iterator. So we're not actually going to compare it with an iterator. So we don't have int I here. So we're actually saving ourselves on a variable by not comparing it with, let's say, I is less than 5. Really a little bit more efficient, this code. So a lot of the time you would have seen something like int I and then having for I equals 0, I less than 5, I plus plus. So we've just got rid of this I and gone straight for the pointers and just not worried about this I. However, that could be a solution, but this is a little bit more efficient, and except for that, I don't like. Can I answer your question, Neil?
Yeah.
All right. Is that okay if I leave it there?
Yeah.
Cool.
Thanks.
All right.
Hang on, we didn't finish the question, did we?
Yeah, no, I just said it was Ila's question.
Oh, right. Okay. Yeah.
And that's a fairly hard one, so I want to focus on some more easy ones so that everyone gets a chance.
Yep.
Okay, so I'm going to go through these 2, and then I'm going to pass one on to Bo to cover after I go through these 2. Let me just check what we're up to on the chats. Okay. Sorry, Josh is annoying.
Josh. Oh, it's the code.
All right. So what I want everyone to do is tell me the length of the string here in the chat. And that goes with the YouTube chat as well, just so I know who's watching. So everyone said 6, so I'm happy. Except for Illa, it's 6. So the length of the string is size 6. So the length is 6. Can anyone tell me the size of the array? Or can everyone say the size? Okay, so the size is also 6. We have 6 cars. So the length is 6. So we have 6 times, how big's a car? 1 byte. So we have 6 times 1. So our size is 6. This is our length. Okay. Okay, because we have one more. We have A, H, X, R, N, and then we have the null terminating character. Okay, so this says where the string ends. So the length is 6 and the size is 6. Now, to question you further, if I was to change this, I can't rub that out because it's a different thing. But if I was to change this to an int, what is the length and size now? Everyone, give me the length and size in the chat. Change this to an int. Everyone. Cool. All right, so I think we've got it. So the length is still 6. There's still only 6 elements. This is now 24 because we have 6 times 4 equals 24. So this is the length times size of int, which equals our size. Okay. Cool.
Noah asks, are those the only 2 we will use?
What do you mean?
In terms of types, you mean, Noah?
Do you mean int and car? No, we'll use float and we'll use a whole bunch of things.
Except you won't be
No.
initializing a float with a string.
No. So remember, you've got two types in types. So you've got car, short, int, long, and then you've got float, and you've got double. Can you type in the chat what these are referred to as? And then what these are referred to as? Have a guess or say I don't know.
Yeah, it helps if you just answer into the chat. Even if you don't know, like Matt said, that's fine.
If you don't know, just say I don't know. That helps us too. So these are called integers, reals. Okay, int doesn't stand specifically for integers. Car is also an integer, short is also an integer, and long is also an integer. If you've done mathematics, you should know the formal definition of an integer. So it's any number without a decimal point, positive or negative. And then you've got reals, which have a decimal point, and you can have floating numbers. Okay, and they're the two groups. You've also got another type, which is unsigned. So you're going to have unsigned integers, and these will not have a, what's it called? Negative numbers. It'll only have positive. Okay. This, however, defines the size. So this is 8. Yeah, 8 bits. Short, it depends on the system. I think on your system it's 16, 32, and then longs. I think longs are actually 32, and then longs are. You'll have to double check on your system what long is and what long is.
More modern systems make it so like ints go up to 64 now as well.
Yeah, I mean 8 bits. All right, so now
8 bytes, yeah.
No, 8 bits.
Oh, yeah.
For the car, it was 8 bits.
Oh, yes. Yeah.
Okay, so first thing to notice is this is a code fragment. Okay, so if you've got a code fragment, it doesn't have the whole code. So we have a little bit of code, and then we have our function. Okay, so it's missing main, it's missing the includes. It's still fine. You just assume they're there. Now, when you write your actual program, go back and have a look at the examples, as they will help you write. Anyways, so we have a string. We then call our function. Once again, S1 is a pointer to the first element. So S1 is pointing to the first element. So we have our array in main, which has a bunch of stuff. So it has an A, a H, an X, an R, an N, and then an null terminating character. And they're all characters. And we have S1. Then we pass that pointer to our function called func. And its name is S, and it's a car star. And we know these are cars, so that's fine. Okay. We then have car C equals dereferenced S. So we have C, and it's type car. So because this is on the right-hand side, we follow the line and grab the value that it points to. So car C equals A. We then say while C is not equal to the null terminating character, which would be this character, already notice that we are trying to iterate until we reach this character. So we say C equals dereference S. Well, we've already done that already, so just put A there again. We then say if C is greater or equal to A. So this is looking at the characters in terms of the ASCII table. So is C greater or equal to A? Yes. Yes, it is. Is C less than or equal to M? Yes. Yes, it is. We have to check both because it's an AND. Okay. So if this was not equal to A as well, then it would never work or something like that. So now we put A where S is pointing to. So now this is a capital A. Okay. We then go to this next if statement. There's no else if, so we have to check both. Is C greater or equal to N? No. We don't have to check the other one because they both have to be true. So then we plus S. This is pointer arithmetic, so it just looks at the next one. Okay. Is C greater or equal to A? And C is less than or equal to M. So this is in the first half of the alphabet. Yes, so this gets changed to an A. Is C greater or equal to N? And C is less than or equal to Z? No. And it's already an A anyway. It's a capital A. I'll show you the ASCII table and we'll do a question about that. So now we increment and we've got Z. Is Z, we've got X. C still, C is H, sorry.
Yes.
So now we say, is this H not equal to the null terminating? No, it's fine. We then set C to the value that this points to, so now it's got an X in there. Is X between these two letters? No. Is it between these two? Yes. So now we put a capital Z there, and we move the pointer. So now we're pointing at the R. Now this is a capital R. So what I want to know, so C greater or equal to A and C is less than or equal to M. So this is false. Give me what you think. Is capital R greater or equal to N and C less than or equal to, and capital R less than R? Write in the comments, or I don't know, what you think. Well, I get up an ASCII table to show you.
Yeah. Also, with this problem as well, if you saw something similar in the exam, you can quickly see after maybe the first 2 or 3 iterations exactly what it's trying to do. And so you don't need to continue drawing the box and pointer diagram, or you don't need to really do much working out at all. You realize that what it's doing is just testing if each character, if it is either between A and M, or if it's between N and Z. And if it's one of those conditions, then it changes to a particular value. So you can quickly just skip ahead and change each value that you haven't finished in the array.
Okay, so we can have a look at our ASCII table. Now, we can note that one of the conditions is true, but the other isn't. So if we have a look, all the lowercase letters are here and all the uppercase letters are here. So we have 6, these are the values of each one. And we can go, is R, capital R, where is it? Is 82 greater or equal to N, it's an N, 110. No, it's not. However, the second case is true because Z is 122 and R is less than it. However, because it's an AND, they both have to be true. We'd actually only check the first one because we don't need to check the second one. And then we continue, as Bo said, once we've worked out what it's doing. So here I can go, I already know this is going to be a Z, so I can just replace this and then come back later in the exam and double check it and go through the whole thing. Okay, but when you're rushing through the first time, I would just see the pattern, try and finish it off, and then come back later and check, does this really equal Z? Okay. So try and use your time appropriately. All right. So the last question that I was sent is, okay, ASCII table. You will not need to know the ASCII table. There's no questions relating to the ASCII table. As long as you understand what characters are and that they represent numbers, that's all you need to know. There's not going to be any complex ones. There's not going to be anything like this. So don't worry about the ASCII table. You're not meant to memorize it. You're not meant to know it. You do not have to know what the numbers represent in terms of the ASCII table. Okay?
I thought I saw in the exam a question which said, what's the ASCII value of B?
Bo.
Oh, what's that? I meant to say that. Oh, what's
Bo is joking? Yes.
As we talked about the length of the string and the length or the size of the array, so length of the while counting the length of the string, we do not count \0, right?
Okay, if you're using string length, no. If we're calculating the length of the array, yes.
Yeah, so the length of the string, which we have used for the previous question, is 5.
Well, no, so the string length is 5. The array length is 6.
Yeah, so
Because the
you
array, yeah?
yeah, so previously you asked what is the length of the string, right? Then
Probably.
I mean, then
Uh,
what were you explaining that both are 6, 6?
Okay, so I'm talking about the array. So the array's length is 6. If you use
Yeah,
the
that I
function string
understood.
length,
But what
if you use
else
this,
was 6 as well?
the size. So if you use string length, it'll give you 5 because it doesn't count the last one. However, the
Yeah.
array length is 6. So that string there has an array length of 6.
Sorry,
So if
I'm
you
just
use
confused. I didn't get you.
okay. So if you use the array itself is of length 6.
Yeah, that is right.
Okay, so the length is 6, and its size is whatever this size is times the length. So if this is a
Yes.
byte, it's 1 times 6. If you use string length, the function, it's going to return the array length minus 1.
Yeah.
It doesn't count the null terminating character. Its definition kind of goes against the array length because most people do not care about the null
Yeah,
terminating
that's
character.
right. But then while explaining the question, you asked us to give the length of the string as well as the length of the array, right?
No, the size of the array.
No, and then
Size.
one more thing you asked, and the answer for both was 6 and 6, right?
Yes.
So
So
what is the first thing?
whoops. Size is 6. So the array size is 6, and the array length is 6 because they're both. It's. Oh. Is it string len or I can't remember what the function is.
Yeah, that's it.
strlen.
Yep, that's it.
If you use strlen, you get 5, but the array length is 6. So the actual length is 6. If you're using string length, it's 5.
Yeah.
All right.
Just had a question from. Are we supposed to memorize the ASCII table? No. So like Matt said, there's no questions on ASCII. Yeah.
That's the question I answered.
Oh, was it? Oh, never mind. I thought it was afterwards, but. Yeah. Also, there was another short question that we missed as well, that right at the beginning. Someone just asked regarding flowcharts if we can use I++, or do we have to write increment by 1? So when we're using a for loop inside a flowchart, can we just write I++?
Okay, so I'll come back to that. Let's do this question, and then we'll go.
Okay.
We'll grab the flowchart examples up because that is a good question, and we will talk about it.
Too easy.
So I'm just going to quickly go through this. So here is a really good question to really understand, and I wish this is actually a really good question. Whoever brought this one up, good work.
Was it you,
So
Matt?
this one, no, it wasn't. I'm kind of disappointed now. So we have a whole bunch of variables. We have result, 1. We have A, which is 3. We have B, which is 5. And we have C, which is 3. Then we have this big condition. So we have if A less than B, or C, oh, that's not in brackets, C equals B, and not result. Okay, so let's break that apart. So we have A, which is 3. Is it less than B, which is 5? Or C, which equals 3, equals 5, and not result, not 1. Okay, so I've just broken it up and put the values in. Now, first thing that happens is 3 is less than 5. What is the result of that? Everyone write something or write don't know? Okay, there is no such thing as true in memory. There's only numbers. So it actually is evaluated to a 1. No, not 2. It's evaluated as a 1. Okay, it'll either be a true is a 1 and a false is, oh, a true is anything that's not 1, but if it's evaluated, it'll be evaluated to a 1 or a 0. Before I move on, do I need to evaluate what comes after this or? Can someone explain why?
That's exactly right.
Okay, so this is actually really important. The compile, at runtime, it will not actually evaluate this. This will not be evaluated, and you can actually use this to do some really cool tricks. Because this is 1, this doesn't matter if it's true. This evaluates to a true because it's a 1 or a 1 or a 1 or a 0. So as long as 1 is already true, the whole condition is true. So what does this evaluate down to? Even if I don't know what this is. A 1. So now we have 1 and not 1. Okay? This is important because if we had like a null pointer here or something, it wouldn't actually be evaluated. So we can actually protect ourselves from funny things if we wanted to. I don't think there's going to be anything complex like that on the exam, but just something to think about in the future. Now, what does not 1 evaluate to? Write your answers or not. Don't write your answers. I mean, all right, I don't know.
It's so confusing, Matt. I thought that was a pun when you said. I thought that was a pen when you said, yeah, not right answers. But
Yeah, write the not right answers.
Okay, so now we have 1 and 0. So what does this evaluate to? 0. Cool. Good work, guys.
nice.
So does this if statement execute? No, it's not a lowercase o. No, cool. However, let's say it did. And let's have a look at this, because this is also nice. So let's say it did. We have this. Now this looks confusing. But we have A not equal to C. So A is what? 3 not equal to 3. What does that evaluate to? Cool, guys. Everyone got that. So 0. So result would equal 0. However, in this case, we wouldn't go inside that for loop. All right. Cool. Good work. All right. So Alex wanted us to quickly go through the flowcharts stuff. So I'm going to quickly open that. PS.
I'm going to quickly be right back, Matt. 1 second.
So now we can talk bad things about Bo. Lifts in mic on, of course. All right, let me just grab it. Where is it? Okay, so with your flowcharts, you've got two options. So this was one of the questions that was asked. There's a whole lecture on the flowcharts and how you should style them. Now, you can either use natural language, so you can write declare input as int, or you can just write the code. It's up to you. So you can write program language. That is perfectly fine. Okay? Okay. So for each of the examples, there's a natural language and there's also a code language, and you can find all the examples. As I mentioned to someone today, are they different? I don't know what that one is. I would, for practice, it's a really, really good example. Okay.
I'm back.
So the shapes. Yes, the shapes do matter. So let's go. I don't think it's on here.
Yeah, the shapes are pretty standard, like throughout industry. Everyone uses the same shapes, you know, for design.
Shut up.
No, well, it's true.
So, I'm joking. So if you go to week 7, and click on, there's an example of all the different loops and if statements and functions. But if you click on symbols, there's all the symbols. So a condition is a rectangle on its side. A function has 2 lines on the side. Any operation, normal operation, is just a box. A return can be either of these. A function entry, you can do either way. It's up to you. And then start is just start. If it's a segment, if it's a function, you need to use function. Okay. We had a question. Yes, it would have been, so the person that just wrote that they got 1 on the quiz, yeah, you would have got 1, because remember I said this was 0, so we wouldn't do this. So result still equals 1. So it's true. Okay, so what I'm going to do is go back up.
I'm going to create it.
And I want to find some good questions. Why is it true? Because 1 is true.
There was a bit setting question up.
I'm going to find good ones that relate to the exam, though. Silly hard ones. Don't worry about macro functions. You won't need them. So I'm just looking through the questions.
Yeah, we had a question by Null, which was Rob has an 8-bit lock. You need to clear bit 1, bit 3, bit 4, and bit 6.
Ah, all right. Cool. Do you want to go through it, or do you want me to go through it, or it's up to you? I don't know. I can go.
Yes. Yeah, I don't have anything set up though for it.
Okay, we'll go through it. All right. This is really, really important for this exam. You need to know your bitwise stuff. We went through it in the lab. Do not forget it. As I said, when you get to the exam, one of the first things I would do is write a table to convert from binary to hex. Okay? That would be one of the first things that I write on my exam paper if you're not sure how to do it quickly. No, 1 and 0 is 0. That is not true. It's false. Sorry. It's 0. It's 0, see? It's false, but result is true. Okay, it's still a 1. We haven't changed its value. Anyways, sorry. Yes, you can call it a what parallelogram? No, you're not using parallelograms. So the first thing that I write on my exam is the 4-bit conversion from binary to hex. And I guarantee that you will need this in the exam. That's a big hint and a big
It's
thing.
Matt's lifetime guarantee.
So I would definitely write this. You will not have to convert anything complex like decimal to binary or decimal to hex or anything like that. This is as complex as they will get. Now, see, so complex that I stuffed it up. So I would write that down as soon as I get into the exam. Oh, dear. God, it's been a long day. And yeah,
It's all right, Matt. It's all right.
I would write that down. The second thing I would write down is set a bit. So setting, we have that is setting. Clearing, now, hopefully you know what these are, but you can, we've gone over these heaps of times, so you can do that. You can evaluate these in your own time.
It is in week 5. No, week.
And nearly every house.
Yeah, week 4 we did bitwise stuff, so that's where you can find the lecture for it and the lab.
And we also did testing a bit, I think. Okay, so these 3 are operations, and this is a condition, okay? So this would appear inside a if statement or a while loop or some kind of condition. These 3 are operations. Okay? We happy with that? I would write this table, this table and these 4 things down when you get in the exam. Okay? 100% I would write that down. Now, the question was, where is the question? Where's the question?
I have it. I'll re-copy and paste it 1 second into the There you go. Oh, no one.
My.
Oh, you're too quick, bro. Photoshop.
Okay, so this is the question that was asked, similar to the cryptolock question in lab 3. Rob has an 8-bit lock. Okay, so we know 8 bits. That's my layer. 8 bits is 8 bits. Okay, which he stores in the variable name lock. So can everyone write what the appropriate variable type would be in the chat if he has 8 bits? What should I declare my variable lock as? And if you don't know, write don't know. Don't know, write don't know. I just want to tell you who's still listening. Okay. If I gave you the option of choosing car, short, int, double, float, would that help? Okay, so we know that this is an 8-bit lock and it doesn't have any floating point stuff, so we can definitely cut them two out. We also know that int is 4 bytes, so it is 32 bits. We only need 8, so we can cut that out. We know short is 16 bits, so we can cut that out. So it's going to be a car. Okay. So remember that car is 1 byte and it's 8 bits. You should definitely know the size of a car, okay, in the exam. Okay, so car is 8 bits. The rest is not as important because it's system dependent, but car's always 8 bits in C. So
I always remember
so
by that there's. I don't know.
Yeah.
Oh yeah, like I always think of the ASCII table, and it's got only 256 characters, and because it's 2 to the power of 8, there's 8 bits. I don't know. It's not too helpful, but that's the way.
So
It
like Bo,
yeah,
that's how he remembers it.
Yeah. So just be like me, and then you can remember it.
So if you want to remember powers, so if you know 2 to the power 8 is 256, then yeah, that's a great way of remembering.
Well, I remember 256, not 2 to the power of 8. I just remember like there's 256 characters in the ASCII table. Then that's
okay.
Yeah.
So we have this lock. Now, we don't know what the values are, but we know that Rob needs to clear to make the lock equal to 0. So we actually do know the values of them, but it doesn't really matter in this question. All we need to know is how to clear bit 1, 3, 4, and 6. So we have our clear, which is lock and equal not 1 shifted to 1. Now, ways, the way I would prefer it be done is ORed. However, I think Josh has done it slightly different in the example. So you could do something like that to clear the bits. You could also put the values here. So we know one shifted one place is going to be 2. And we can do it that way. I prefer this way because I think it looks neater, and if you start using macros, it works a bit better. You'd have to show me which and how Josh did it to get his answer, but that's how I do it. And the reason I do it that way is that we get 0, 0, 0, 0, 0, 1, 0, ored with 0, 0, 0, 0, 1, 0, 0, 0, and we get 0, 0, 0, 1, 0, 0, 0, 0, and we get 0, 1, 0, 0, 0, 0, 0, 0, and then we all of them together to give us 0, 1, 0, 1, 0, 1, 0, 1, 0. And then we do a knot to that. So we get 1, 0, 1, 0, 1, 0, 1, 0, 1. And then we AND it with our lock. Okay.
Yeah. Oh, so it's important to note that when you talk about the bits, you start from the 0th bit. So like the first bit is actually, it's the second one along from the left. So you index it exactly like an array. There's 8 bits, but the first bit is the 0th bit.
And it's the smallest one, is the 0th. Okay. I don't think you'll need to know how to do multiple at the same time in the exam. As long as you know how to do these ones. This one's a bit more tricky because you got multiple. But know these, as you'll probably get more questions relating to these than something long like this. Okay. How to get hexadecimal for the 1, 3, 4, and 6 bit. Okay. So if we want to know the hexadecimal, let's have a look at it. So I've got 0, 0, 0, 0, 0, 0, 1, 0. So I know I can break this up into 4s. Okay, and if there's one extra, I can just add more zeros. So I can go look at my table, and I can go 0, 0, 1, 0 is a 2, and zeros is a 0. So my hex number is 0, 2. And that is bit 1.
And you'd also write 0x out the front as well. Typically.
If you're setting it.
Yeah.
Okay, bit 3. Break it up into 4s. I added an extra 0, and all that. Look at our table. We've got a 1, 0, 0, 0, so it's an 8, and we've got a 0 at the front. So the hex version would be 0, 8. Does that make sense? And you can keep following on. So we can do a couple of quick examples with hex to binary.
So Nell's been asking if you do the first, third, fourth, and 6th bit. I think that means that if you had those bits set and all the others not, how would you get the hexadecimal value? I suppose we just use the technique we just did.
Oh, no, the question was how to find the hexadecimal from the ones. Oh, so yes, so we can just write not 2, 8, in hex. Then we can write hex. Now this one here.
Oh, I got you.
1, 0. And then this one here is going to be 0x 4, 0. Okay, and that's how we write it in hex. So let's just quickly go through some hex because I think people are still having trouble with this. So if I have the number 01010010 as suggested, put in the chat what they think the hex number would be. At 10. Okay, so everyone in the Hangout got that right. So if you've drawn your table correctly, now there is a pattern here, so you can double check your table. It's 01010101 on the first column, then 0011, 0011, 0011, 0011, and then 4 zeros, 4 ones, 4 zeros, 4 ones, and then 8 zeros and 8 ones. So if you need a way to memorize it, you shouldn't need to memorize it, but if you do, there's a way. And then this just goes 0, 1, 2, 9, A, B, C, D, E, F. So as we said, we break it into 4s. 0, 0, 1, 0 is this one. So we have a 2. And then we have 0, 1, 0, 1. So we have 0, 1, 0, 1. So we have 5. So we get 0x 0, 52. Or if we want to write it mathematically, we can put a H here. Or the other mathematical way to write it is 16 there. Okay. Do you convert to binary and then hex? No, you can convert directly from hex to decimal and decimal to binary. You can convert any number base. You can convert to base 17. If you do, it's not relevant for this exam. If you do, what's the math subject?
Discrete
Yeah,
mathematics.
if you do discrete mathematics, they'll teach you how to convert to any base. But I'm not going to confuse everyone and explain it here. If you want to ask after the exam, we can show you how to do it. But for now, we're just looking at between 2 and 16. Cool. Or just look online. There's heaps of examples. So the lock question is somewhat important, but not that question exactly. There's better ways to write it. So use the one that you did in the lab. Josh has written it in a confusing way. Try and use these instead to clear and set bits, and do it. Just do 4 steps if you have to. Okay.
If it gets it done, it works.
Yeah, exactly. So, no, there's no octal. As I said, the only conversions in the exam are going to be between binary and hex. You don't have a calculator, so we're not expecting anything complex. Decimal is enough that you'd need a calculator. So binary and hex, all you need to know is this table to convert. So that's the only conversions you'll need to know. Okay. So let me just do one more quick question. C 5 3 1. I want it in binary and suitable type for storage. Okay, let's put that in the chat. Just so I know everyone's getting it, and we can leave that there and just be done with it. Where'd my mouse go? Right, don't know. And I'll come back to your comment. Bo, can you just check that the answers are right?
Yes, so we've got
I think
Illa's and Chris's are both correct. Yep, so I'm not going to say out loud what the value in binary is, but the correct storage type that you would want to use for this value is short. And I can see a few of you wrote that down. And that is because there's 16 bits in this number, yeah? So each hexadecimal position corresponds to 4 bits. So, you know, the 1 is written as 0001. The 3 is 0011. So each one's 4 bits long. And so because we've got 4 values here, we've got C, 5, 3, 1, 4 values or 4 positions, and each one's 4 bits. There's 16 bits. So a short would be the best storage type for that because a short is 16 bits long.
Okay, so further than that, there was someone that asked about the leading zeros. So these are just numbers. It follows the same rule as normal numbers in maths. There's nothing different. So if I have 100 in decimal, is it any different from 100? It's the same number. 100 is a bad number because it looks like binary, so I'll make it 200. Okay, they're both the same number. However, what will change when we're using it with C is the storage type. Yep. So if I use int x equals 0 b 1101, how it will be stored, because this is 4 bytes, it's going to be 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 1 0 0 0 0 1 1 0 1. There's all these leading zeros because it's got to fill all these empty spots up. Okay. Okay. Yeah, it'll wrap around to negative. Okay. So there's another question. I'm just going to go through this quickly as it's not really that important with the exam, but let's say we have I'm not going to use an int, I'll use a car instead. So 1, 2, 3, 4, 5, 6, 7, 8. So if we've got a signed car, can anyone tell me how the range? Yep, cool. So signed car can go between 127 and negative 128. Oh, that's a big moth.
I can hear the fear.
It just came from behind me. Okay. It's actually 128 because we're dealing with 2's complements. So we need somebody to store the 0, but we actually get an extra. massive moth. Now, where this negative gets stored is in this first bit. So all these other bits are all the other numbers. This here tells us if it's negative. If it's a 0, it's positive. If it's a 1, it is negative. So if I have 127, then all of these are 1s. Okay, that's 127, and this is 0. Now, if I add 1 to this, this will become a 1. And all the rest will be zeros. This will be a negative number, and it'll be, what's it called? Negative 128. This is because of 2's complement. I'm not going to go through how that complement, I think it's how you spell it. I'm not going to go through how that works because I want to focus on other things that are more pressing for the exam. If you want to know how 2's complement works, it's quite an easy algorithm. Just invert and add 1, and you'll get the negative number. But that you can do for your own research. I'm not sure if it was covered in the lectures or not. Okay, so that's what overflow is. You can also overflow an unsigned number as well. So you can have all 1s, and you'll try and put bigger numbers in it. Or you can have a number that's too big for the storage size. So if I try and store, let's say, 1,000 inside something that can only hold between 127 and negative 128, we have overflow.
Yep.
Okay. Cool. Don't worry about that too much, though. All right, there was questions. What time is it? All right, it's time for a 10-minute break.
Sounds good.
If you've got questions, because some of the stuff's flying fairly quickly. So I'm missing a couple of questions. So
I've written down. I've got one.
Just type your questions again. We're going to focus on things that are more about the exam and questions that haven't been covered. So things outside of, let's say, Lab 12. Lab 12 we'll do last because we went through that in the lab. Multiple help sessions. How many questions in the exam? Keep writing your questions. I'm going to have a quick break and I'm going to get rid of this moth. I'm going to mute.
Sounds good.
All right, we're back. You there, Bo? No way. Okay.
Hello.
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 How are you?
I'm good. How you doing? Can you hear me?
Good. Yep. All right.
Yes, I'm there. Yep.
Just some quick questions. So file stuff. There's someone asking about file stuff. All you need to know for file stuff is basically what each function does. Don't worry too much about file stuff. There's not going to be any hard file stuff questions. You're not going to have to write your own program for file stuff. But you should understand the lecture content about file stuff. Okay, understand what each function is, and that should be enough knowledge for the exam. Now, there's another question. The minimum flow chart. Yes, it's another one I want to go through. No, you can't use a parallelogram.
A few people asking questions about Lab 12. We will go through those towards the end.
Yeah, because we've already covered them many, many times. We'll do them last. Okay, let me have a look at this one from the exam, because that's a very different question. While I look for that, in terms of storage types, I talked about if I needed to store 8 bits or 32 bits. What if I needed to store a bunch of different things? Let's say an int, a float, and a car, but I wanted to keep them as a collection. What would I use? So while I find that, write your answer in the comment section. 2009.
I'd use a int float car array. All 3 types together.
You may be laughing, but I can show you a way that you can actually do that.
Magic.
No, so you can do it with dynamic arrays.
Yeah.
It's interesting, but it's efficient. It's really efficient.
Would you just treat it as void, and then
yep,
you convert it? Yeah.
Yeah. But what you'd actually do is have a collection of ints, a collection of floats, and a collection of cars, and then you'd have offsets.
Yeah.
And you have a pointer to each one. It gets interesting. And then if you need to add to that, so you can actually have a list like class, or I mean list function, you can add to that list in each block, and you extend the size.
Yeah.
With realloc. Now I'm just having a look. Exams, 2009. And if you don't know, just write I don't know.
Yeah. By the way, what Matt and I were just talking about is definitely not on the exam. You won't find that at all through uni, I don't think.
Right.
So I was just joking.
What a horrible question.
So
sorry,
people wrote as answers to the question Matt just asked. So the question was, if you wanted to store an int, float, and car together, so 3 different variables of one of each of those types, and you wanted to keep them together as one cohesive unit, the best way to do that would be with a struct. So I noticed in the Hangout, everyone answered with struct. So that's the best thing. So you could create just a struct, and it would have 3 members, one of type int, one of type float, and one of type car.
So we're going to have a look at this. Let me see if I can just print screen and make a copy of this. This was one of the questions that was asked. It's a reasonable question. Now, with the previous exams, so this is 2009, question 1R. Now, with the previous exams, they're a little sloppy in terms of the functions are written above main, which you can do. However, in your exam, they're always going to be below main. And there's going to be a function prototype. Okay, so you're not going to see something ugly like this. Instead, what you're going to see is this, then this, and then we'll keep the same format. And this. Okay, so all yours will look like this. Okay, so the questions in the previous exams, stuff like this. Yes, there will be some hard ones. Yes, there will be some easy ones. In the previous exams, there were some hard ones and easy ones. There's at least one very hard one in terms of the tracing. There's a couple of hard ones, and then there's a couple of easy ones. It's probably one hard, one really hard, 2 hard, 3 medium, and a couple of easy, something like that. All right. So we have this question here. Now, you need to know what all the string functions do. Okay, that's important. So you need to know what string length, string copy, and string compare. Know what these 3 do. 100%. Okay, at least one of them will, or more, will appear on the exam. Okay, because that was a whole week's topic. Okay, so do expect it. All right, so this one here, we start in main and we create a string of length 100. String cat, very much. I wouldn't worry too much about string cats, I don't think. Yeah, don't. It's good to know, but the 3 ones that you use often are going to be string compare, string length, and what was the last one? String copy. Yeah. All right. So this function, we create a string of length 100. I'm not going to write 100. I'm just going to write dot, dot, dot. And it's empty. So it's a character array, and it just goes up to 100. Then we create int x. So we've got an x. We don't know what's in here. We don't know what's in here yet. We then copy the string support into this string. Now, the first argument here and the second argument here are both pointers to the start of an array. This here returns a pointer to the start of array support, and this is a pointer to array. So that's perfectly fine. Remember, st points to the start of the array. Okay, so all we're doing here is putting support here. And don't forget, it'll have the null terminating character, and then it'll still have a bunch of where did stuff go? It will still have a bunch of stuff after it, but because this null terminating character is here, it's going to ignore what's after it if you try and print the string or use the string normally. Okay. So now we need to find that again. The next thing happens is we've got x equals func, 0, and st. So we now go into our func, and we've got 0 here, and we've got a pointer to s. So y points here. Okay, and this is in our func. So we have x, which equals 0, not the same x that's in main. We have y, which is a car pointer, and it points to the start. We then say if yx equals p, so we have yx, it looks like it's the wrong bracket, but it's the right bracket. So this is saying y0, and we can also represent that as star y plus 0, which is the same as star y. So is star y, which is an s, is s equal to p? No. This is a really kind of hard question.
Yeah.
Okay, so now we've got recursion.
There's so many levels.
This,
Like,
so this is actually a really hard question, so don't stress too much if you don't get this one. So now we're sending x plus 1. So x was 0 here, so we pass x equals 1. And then we have y, which points to here again. And it returns that function plus 1. Okay, so we're still in here. We haven't returned anything yet. So then we go y1 equal to p. No, it's u. So we call the function again. Now this is what is called as recursion. So now we're sending x plus 1. So we've got x equals 2. And then we've got y again here. So now we've got 3 copies of our function. Whoever picked this question. So now y equals 2. And we got y2 equal to p. So now we can say, yes, it does. So return 3. Okay. Now it's returning 3 plus 1. Okay. That equals 4. Now this function also returns, no, that returns 3. This one returns 3 plus 1. So we get 4. And then this one returns, so we get 5. So what we get printed in X, okay, that is a fairly hard question. You're not going to have recursion on the exam because we didn't cover it in the subject. But it's a great question to test your understanding of functions. Okay, so it's a function calling itself multiple times. But we didn't do recursion in the lectures, so you don't have to worry about that. Okay, but it is a good question to test your knowledge of functions if you really want to challenge.
Yeah.
Okay. All right. I'm going to throw out another question.
I think we answered all the ones that have been put out, essentially.
No, I'm just going to ask a question while we have a look.
Oh, the minimum flow chart.
Which of these is a valid variable name? Valid.
Is that an underscore or a dash?
An underscore.
Yeah.
If you don't know, just write I don't know. Who's messaging me? So, which ones are valid?
So Nell, the question was, which of these names are valid variable names?
Okay. So there's actually two here. And I was being a bit tricky. So it's this one and this one. These two are not legal. So the reason for this one not being legal is it is a keyword. Okay, you cannot call your variables keywords. So you can't call it int, you can't call it main, you can't call it return, you can't call it if, you can't call it break, etc. You can't call it a keyword. This one's wrong because it has a space in the middle. Okay? This here is legal. You are allowed to start.
I think you can call a variable called, you can call it main because main's not a keyword.
Oh yeah, that's true. Not that one. Now you can start your variable name with either underscore or a letter. Okay? You can't start it with a number though. Okay, you can have numbers in it, but you can't start it with a number. And this is legal because C is case sensitive. So this is actually not a keyword. However, it's a really bad variable name. Okay? If you did that in this assignment, I would have cried. Okay, so that was just a quick questions.
Tell your friends to do that in the next assignment next year so you can make Matt cry.
Make me cry and you get 0.
I'll give you 100. I'll change it.
Now I've done that. Okay. How would we create an array of floats dynamically allocated to the size of variable b. So I had variable int b and I scan something in. So D, address B. How would I create an array of floats dynamically allocated to the size of variable B? The live link. Write the whole statement. When will the live stream finish? When we run out of questions? Or when Bo gets sleepy?
Never, man.
He's gonna sell.
I'll go get some coffee. Caffeine. What?
You can call the array whatever you like. This is a really, really important question. And if you don't know, right, don't know.
Yeah, throw out some answers, guys. So if you know how to do it, type how to do it in chat, and if you don't know, then type don't know, because that also helps us as well. It helps us know what you guys don't know.
Cool. Oh, no. Okay, so the answer would be float star C, because remember malloc returns an array. We can typecast the malloc to float star. Then we use malloc, because remember malloc returns a null pointer. I mean a void pointer, sorry.
Mm-hmm.
And then we have size of our type, which is float, times B. Okay. The B should be outside of the brackets because we want the size of the type. Okay. You should know this by now. Okay. Make sure you know this by tomorrow. Okay, this is really important. And make sure you know what it means. So we have a pointer called C, and it points to an array of unnamed variables. Okay. Don't forget the semicolon and all that. Understand this. There is no brackets here, which I saw in one answer. I've lost where I am. There it is. There is no anything else. It is purely this. Now, I'm going to extend that even further. I'm going to change the question. And I want you to have a go at it again. Oops. I didn't mean to get rid of that. So I'm going to change one thing just to make sure your understanding is there.
It's really trippy how half it's red and half's purple.
Sorry. What I'm going to do okay. So try that question again. So it's an array of pointers this time.
Even just have a guess, guys. So just type some answers into the chat. What you think is right. Don't be afraid to do the wrong thing. Yeah, because then if we see what part of it you're not understanding, then we can, just discuss what you did wrong.
What I did wrong.
All that.
No, it's not float by itself.
Only that simple.
But I put web 12 there. Really? Hey, Bo, can you do me a favor?
Yes. Mm-hmm.
Can you check if there's a mistake in the answer sheet for the box and pointer diagram for part D?
Yep.
What I find, the thing I wanted. Oh, I know what I wanted. The sorry. What's the question? Um,
So A is correct.
where's this one to header files. Week 11. Week 12 flowcharts. Okay. Someone's laughing.
Oh, that's through my mic.
That's okay.
No, it's my roommates. I know how to turn down my mic. It's actually John, I think.
Damn, John.
Yeah, I know.
Okay. So let's look at the answer. I've got some interesting answers. So we want pointers that point to objects of type float. So this is just saying pointers to floats. Okay. So we know that our malloc, we are looking at size of float star now. Okay, because we want objects of type float. So we want an array of pointers that point to floats, which is a float star. And we want that times by b. Now, if we have to point at a float star, it needs to be a float star star. So we just have float star star a equals blah, blah, blah. Okay. There's no array here. It is just, I mean, there's no two-dimensional array here. It is an array of pointers that point to objects of type float. Okay. So double check your answers because that is really important. And I'm going to change it one more time. Okay, so just write that down if you're still not sure about that. And I'm going to change it one more time. In a second, I just want to get this lecture notes up. So there's one thing I want to go through. All right, so I think everyone's had a chance to look at that. It's null.
Oh,
That's funny. No, you're like, hey, null. All right,
wait,
so I'm going to change this question.
Yeah,
I don't know. All right, so I'm going to change this question one more time. I'm going to get rid of B. I'm just going to say an array of pointers that point to the type float of size 6. So this time they're not dynamically allocated. So how would I do that? Okay. So the answer is float star A6. We have an array of pointers that point to objects of type float. So an array of float star. So remember with malloc, we need a pointer to the first element, which is going to be a double pointer because it means that it has to point to a bunch of float stars. So remember A by itself is a float star star. But the actual array is float star. Okay? Cool. All right. All right. So the next thing I want to go over, which is really important for the exam. What? Actually, I might take a screenshot. Copy it. What are you laughing at? You stuffed it up.
Oh, no. No, what, me? No. It's okay, Chris. The chat.
Someone's going to apply.
Yeah. Yeah, I went over part D. It was fine.
All right. You want to go over that later?
Yeah, sure.
Because really, I've done that like 6 times. It's 8 times now. Okay. So the next thing I want to go over is, this was one that was done in the lecture, and I think it's a really important example for reasons. Where is that? So here we have our code, and then we have our flowchart. So we start our function, and then we set aside memory named min for storing the minimum value. So we create this value here, min. Now, what? Okay, let me have a look, because I think he's doing this weird.
Uh-oh.
Oh no. Okay. It's done a little weirder than I would have done it, but that's okay. It still does make sense. So we have float x is 10. There's no variables though. This is an odd question example on the lecture. It didn't really make much sense. Not my fault. All right, so let's give these some values so that it makes sense. So let's give it 1, 4, 6, 3, and 2. And let's set this to
5 instead, just so that we can speed this up. I is equal to 0, and we've got min. Oh, he's collecting the values there. Stop it. I'm just not going to bother with that. So this function kind of starts here, really. Okay, so all we're looking at is this. Okay, the other stuff was just getting the values, so we'll ignore that. So this is going to be 4, and that's all good. So we've got I equals 0. I don't know why I wrote that twice. Let me just write it here. Okay, so we've got min equals x 0. So min is currently equal to 1. Okay, so while I is less than 4, we increment I. So now I equals 1. I equals 0, now it equals 1. If x1 is less than min, what the hell has it done? Oh, I don't like this notation. Okay. Please don't write it like this. This is confusing to people. Okay. I get why you had trouble with this. It's written kind of poorly. I might just write this again because this is just ugly. Sorry about this.
Don't swear, Matt.
Okay. What? Yeah. I'm just going to do ints. Okay, so we have a bunch of ints. Okay, and we're going to call it A, and they're 5. Okay, so I've got 1, 2, 7, 6, and 2. Okay. And our algorithm works by checking, firstly, is it the last number? So firstly, it sets the first number in the sequence to the current number, and it takes the current number and sets it to min. And then it goes around until it looks at every number and then prints out the minimum. So how it does this is that the next number is the current number. Is the current number less than min? Yes, then the current number becomes min. So we'll go through this. I really don't like how that's written. Okay, so I'm going to do it slightly different. Just because I think it makes a little bit more sense. Okay, so what I am doing here is going through and looking at every number. I start at 1 because I've already looked at the first number here. Now, what I do is I create a variable called min. Okay, and I set aside memory name min, and then I set the current number to min, and my current number is the first number in the sequence. That is written really weird. So int min equals 1. Okay. Yes, I know you don't need parentheses in one-line statements, but I want to make sure that everyone understands it and it's not something that was introduced. So I want to keep it clear. You're welcome to not use them, but for anyone that's really new to C, I prefer to keep a common standard and keep it nicely explained. Okay, so my min, no, it's not one, is the first value in my array, which is A0. So it's equal to 1. And then all I'm going to do is each time I go around, if A, I,
is less than min, then I'm going to set min equal to AI. Okay. All right. So this might be a little bit nicer, especially for some of them students that got confused with this question. This isn't written more in a way that you've seen in the labs and other examples. So what we're doing here, and my pen's upside down, we have min equal to 1, then I equals 1. Then we go here, is A1 less than min? Is 2 less than min? No. This was a bad example. Let's make that 0. So we go back up, and now I equals 2. Is A2 less than min? No, 7 isn't less than min, so we go back up. Is I3 less than min? So is A0 less than min? Is 0 less than min? Is A3, which is 0, less than min, which is 1? Yes. So now the min equals A3. So we're saying min equals 0. Okay. Then we keep going. 4 is 2 less than 0? No. So we're done, and we got the minimum value, which is 0. Okay, so try and understand how that works. It may be very useful for the exam. You can write it like this, but I think for most people, this will be an easier way to understand it, as it's more similar to what you've done in the way we've tried to present it in the labs. Okay. Yes, you can use one-line statements, but I don't really like when teaching C.
Cool.
So, yeah. All right. So, hopefully that answers your question about how to get the minimum. Basically, we're iterating and then setting the smallest number to the minimum as we iterate over it. Okay. So I would follow this example if you want to follow this flow chart, because it's more similar to what you've done in the labs. All right. So that was one question I did want to go over. Now, if you've got more questions or really good questions, put them in the put them in the chat, or else I'm going to chuck some more questions out, and then we'll go over box and pointer. We'll go through the lab 12, some of them questions again. I want to make sure that people that
Matt and I will answer questions all night. So if you throw them at us, what happens to the exam? Then the live stream will stay open.
They've got most people have a maths exam in the morning, don't you?
That's pretty harsh, to be honest.
No. Bit of dy dx integration. And fun stuff.
Focus up with the exam.
What, the calculus exam? Or the C exam? Both. Oh no, that's being greedy.
Yeah, it's pretty greedy, man. Not going to give it to you now. I was going to give you one, but you asked for two. So.
Yeah. Don't worry, the calculus exams are easy.
Says Matt.
I fucking killed that shit. What was I gonna say? Here's another question, which I enjoyed in the help session. Not help session, the lab 12.
Give me.
Okay. Go ahead. It's a fairly easy question, but it's really important. So that's one question. Second question is,
Yeah, that's good, Illa.
except for it's only.
Oh, it's 4, but like it's good. The other 2 are hard. Well, not hard, but like it's.
You can repeat them. 6 examples. A. That does say program. My pen just slipped. Change the color.
Yeah. Type out your answers, guys. Illa's written
I'll
out
say
an
I
answer.
don't know.
That's a good one.
Math.
Bo wants to help.
YouTube chat.
Rip. That's so funny, man. Wait, don't say that about programming, bro.
That's the command line in red.
Bo want to help.
I'll steal everyone's examples. A0, ABC, 0.34F, 0x25. We could have 0B, 0101. We could have 4LF, long flow. We could have a negative number.
Would you consider like an array a literal? So like if you do like this squiggly, if you do like a brace and then some values inside.
The values are literals. the array is not literal. So the values would be literal, but the array itself isn't. So they're just literals. They're just numbers that are literally the numbers. This second question would be 4. 1, 2, 3, 4 for argc. And you should also know what argv does. Can you give an example for an error message? Sure, let me create an error message. Let me create one in real life, because that's even better.
Segfault that.
No, it's not going to be a segfault.
Compiler error.
Let me make an error. Oh, it's kind of long. Just going to make sure it's checking.
Yeah. But you know how you have a string literal, Matt? Wouldn't that technically be considered as an array? So if you're declaring array, like, you know,
it's still literal string.
Yeah, in text, but
What? What did that not give me an error? Oh, I know why. Okay. Here we go. So I've got an error. Just wondering if I can get a good error. So the Unix errors are kind of better than the ones you'll expect on the exam. This one's a little bit horrible.
so we have the question, what are the main definitions we need to know, or key definitions? Do you mean like what concepts we need to know, or what are the main ones you need to know?
But yeah, there's an error. Oh, I didn't mean that. Wait, did I not copy the whole thing? Well, they're two separate things. Them two are related, so you can play around with them. Unfortunately, I need to open. Key definitions, you just have to go through the lectures. There's so many definitions that it's like any subject. There's not going to be one answer for that. Okay, what concepts do you need to know? Okay, that's easy. That's really easy. So we've just done the whole subject. We've done 13 weeks. We have, don't worry about that. Program structure, arithmetic expressions, operations, basic data types, typecasting, printf, format specifier, conditional statements, flow diagrams, scanf and getcar, binary, hex and decimal, data types, signed and unsigned, overflow and underflow, loops, flow diagrams, bitwise operations, specifically set, clear, toggle, and test, arrays, flow diagrams for functions, bitwise operations, so masks and flags. They're just an application of these. Scope, pointers for functions, memory diagrams, so this is box and pointer diagrams, pointers for arrays, strings, and malloc and calloc, basic macros, so only basic macros. You don't have to do macro functions, structures, string functions, command line input, file input and output. And there won't be any debugging. There won't be any testing. Well, except for the knowing what the errors do. But this stuff won't be on there. And the header files, I'm pretty sure is not on there. So all of this stuff, yeah. Okay, they're the main things that you need to know. Okay, and there's lectures for each one of those. All right. So
Matt, sorry, maybe I missed. Do we have header files? Like, is it important for the exam?
No. No.
Yeah, okay, thanks.
Error means that you passed an int into a function that was expecting a file pointer. Yes. Unfortunately, this isn't a very good error. I need to open up Unix to get the good error messages because I'm using a different compiler. So that was kind of a bad example. You're right, Chris, but the GCC error messages are a little better, and it'll tell you which function and stuff like that. So I might actually try and do that. All right, so what I'm going to do now, I'm going to just quickly, because I don't want to spend too much time on it, because I know there's more important questions. Okay, which questions on Lab 12 would you like me to go over again? So put a list of questions. Don't just say all, but the important ones. And while you wait, what I want you to do is, so this is another question for you. Test you, create a code fragment that takes a number from user from 1 to 3, and if 1 prints A, if actually print, let me think about this. Print A. If 2 print B, we'll change this question around and make it a bit harder. If 3 print C, else print D, and do it all using a case statement. Okay, that's the question I leave for you while we look at the questions from 12. You should know how to do this. Okay, case statements are important. Ones that relate
Press
to the
and check,
exam.
guys.
What?
All right, press and check, guys, like your answer. Then we can tell you how you
Or
went.
email it to Bo.
I'll do that. That's cool.
Or send it by post.
Yeah, that's preferably.
What?
Oh, Al. If you got an Al, do that.
Lab 12, the questions 1 to 12 were specifically, no, 1 to 10 were specifically chosen. No, 1 to 12 was specifically chosen because of the exam.
questions 13 to 25 were chosen because they could be on the exam.
That's a big hint, guys.
What's a big hint?
No, I was just saying what.
Oh, me. I thought you meant something
Yeah.
you typed.
No.
Okay. Okay, okay. I'll let people have a go at this, but while you're having a go at that, please understand that the bit lock is just a problem. It is not a concept. Okay? The theory questions will be tested in the multiple choice. So the idea of a bit lock is just one application of using bitwise operations. Bit lock is just an application. You could use bitwise stuff for a lot of different things. Bit locking is not a concept that was taught in this subject. It is just an application. It's like we used C to create to create an audio file. Writing to a file is not just for creating audio. Bit locking is just a concept. Okay, so make sure that you understand that bit lock is not a concept, it's just an application. Okay, so everyone have a go at that question. This is stuff from very early on in the subject. But no, you won't have to write any English answer questions. We already tested that with the written part of the, what's it called?
Yeah. You said question in lab 12 questions 1 to 15, was it, were important?
Well, no, none of them were important. They were written for it. The rest are just from the quiz, randomly chosen from the quiz.
Yeah.
And they're all relevant, and maybe even more relevant than the first couple. They could be exactly the same ones as in the exams. I don't know.
Yeah.
The first questions were more specific. The later questions are random.
So Chris has got a good.
Yep, I think I like Chris's answer.
Yep, that looks good.
Okay, so I'll give a couple of minutes for everyone to
In fact, that is correct.
So what I'm going to do is move this over. And if you've finished it already, I'm going to change this slightly. If you get a 1, I want it to print AB. If you get a 2, I want you to print B. If you get a C, I want it to print CD. And if you get a D, if you get else, I want you to print a D. Okay, so that's the second version. We're gonna have a quick break. No validation. So while we have a quick break, I'm just gonna be like 2 minutes.
Too easy.
I'm just gonna put some, I got rid of the moth too.
You should have put it on live stream. I wanted to see how big it was. Like how big was it? What size are we talking here? Was it like one of those killer moths that's like the size of your palm?
It was a big one. Yeah, it was about that big.
What?
It's a massive one.
Where do you live, bro? Jurassic Park. What the?
It's bigger than my mouse.
God damn.
Yeah. All right. I'll be back in 2 secs.
No worries.
Okay, I am back. So I'm just going to copy
Welcome back.
Chris's answer because it's the correct answer.
Yes, Chris is correct.
Okay, so some of the people have forgotten one really important thing, and this is the first one. Do not forget the break. Okay? So remember, if you don't include the break, it will fall through. Okay? Here we have, if it's 1, then it'll print out A, break, and end. If it's 2, it'll print B, it'll break and end. If it's C, it will break and end. If it's default, then it'll break and end. Okay? So this is really important that you put this break statement in. Now, Chris also did this one correctly, taking advantage of that fact. Listed it somewhere, I don't know where.
There we go.
So here, this is a really nice solution. So if it's a 1, it'll print an A, and it will fall through and print a B, and then break. So it'll print AB. If it's a 2, then it'll only print the B and then end. If it's a 3, it will print the C, then it'll fall through and print the D and then break. So just make sure you understand how these break statements work. Okay, there will be break statements on the exam. All right.
So, Matt, for the same question, is my solution
Yeah.
wrong?
No, it's not wrong. This is just nicer. And that's what I was trying to get the whole break thing.
Right.
It's yeah. I was just trying to show that point. That's why I like this solution. And that's why I specifically chose these letters. But no, your answer is right. Yeah. All right. So I'm going to go through the first 3 steps of the box and pointer diagrams because it has been asked.
A few times, yeah.
A few times. We have covered it multiple times. I'm not going to go through the whole thing because it has been covered to death. But I will do this quickly just to not bore everyone. Please give us
questions. If anyone has any questions, we keep throwing them out.
Please give us questions that are similar to this level. Do you mean questions like this that I just put up? Yeah, I can produce some more questions. That's fine. What I recommend you do is while you're watching this, open the quiz up and just look for questions in the quiz that you don't understand as well, because a lot of our... Please do B, C, D instead on box and pointer. Well, I have to do A first because, I can't skip A. All right. So I'm just going to screenshot that.
No, so we don't use go to or continue in the exam. I don't think we even, we might have briefly covered in the course, but they're generally considered not good programming practice to use those statements. Yeah, go to is pretty evil. That's right, Chris.
Don't use them. Not particularly. What if you're using...
No, that's a blanket statement.
It can be useful. Especially if you're using assembly.
Yeah.
There's no assembly on these.
Well, you can only do some things in assembly with go-tos. So, yeah. I think go-tos might be used for time critical applications as well. So if you're doing stuff, I don't know, if you're doing flight software or something, you might have to do a go-to so it doesn't take forever to get out of a loop.
It depends on what instruction set you've got. Depending on the jobs and go-tos. There is...
Yeah, so
assembly isn't like C. You may have done assembly, but you've got to remember that there's a whole set of architectures and you're most likely using RISC. But there's a whole bunch of them. Don't worry about that. Okay. All right, so we're going to go through the first 4. So first one, we're in main. So we create a box quickly, write main at the top, and we have 3 boxes. And we go boop, boop, boop. They're all cars. Car. This is A, this is B, and this is C, and this is set to 2, and this is set to 3, and this is set to 4. A is done. Then we go to B. So we still have in memory this A, B, C. Now, if you want to put a shorthand notation, just write a note. C stands for car or something like that. So just write C. It's C, A, B. 2, 3, 4. And then I'm going to have a bunch of pointers. So C star, C star, C star. I've got pointer X, pointer Y, and pointer Z. And these names are kind of handy because they tell you exactly what they are. This one's a star. So now we need to say that pointer X points to the address of A. So we just draw a line and point it to A. We say pointer Y points to B, just point a line. And then we say pointer Z takes the address of pointer Y. It's a double star, so it can point at a single star. That's fine. So you double check, just make sure your pointer points to something with one less star. We're not going to trick you. We're not going to put anything that doesn't work there. In C, we have two functions. So we have our main and we have our func. So up here, our memory still hasn't changed. So I'm going to draw it again. So we've got A, C, B, C, 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 4, 3, 2. And then we've got pointer X, C star, pointer Y, C star, and then we've got pointer Z. You'll have a bit more room on the exam than I do here. And then we've got this pointing up to here, this pointing to here, and this pointing to here. Cool. All right. Now, in our func, the first thing I would draw is this. Okay, so I've got E, and it's a car. I've got F, and it's a car star. I've got, and it's a car star. And then I've got I, and it's a car star star. Okay, then I'll start grabbing the values. So I've got A in this first one. So A is 2. Then I've got the address of C in F. That is an F. So the address of C, so I'll just draw a line there. It has one less star, so that's fine. The third one is the value in pointer X. So the value in pointer X is this. So we take the same one and we point it at A. Okay, it's grabbing the value. All right, and to double check, this has one less star. Beautiful. And then the last one is pointer Z. So pointer Z has this value. So we grab the same value and we also point it here. Okay, cool. Then we go on to D. So we have a look at this first block and we see we grab the value that F is pointing at. So F is pointing at a 4. So we're saying E equals 4. And then we're saying, so we always look at the one before. Then we say, we grab the value that G is pointing at. So G is pointing at 2. So we say star F equals 2. So we store it where F is pointing. So F is pointing here. Okay, so now C, or this memory address equals 2. So I can just redraw this and go A, C, 2, B, C, 3. I know F, what it's pointing to is a 2. So we've got C, C, 2. We've got pointer X, C star, and it points to here. We've got pointer Y, and it's a C star, and it still points to the same plot. Pointer Z, and it's a C star star, and it points here. And then we change the value of E because we changed it to 4. So it's a car and it's 4, and then all the rest of these don't change because we haven't touched them. So a quick check to know if something has changed or not would be to go at what is on the left-hand side The reason being is that the left-hand side is the only things that can change their values. So, did I point that at the wrong thing? Yeah, I did. So, unfortunately, you won't have an undo button on the exam. You'll have. I recommend a pencil. Okay, so the reason I can double check this by going. Oh my god, go away. No, don't do that now. I can double check this. I know that E changes. So I know this one changes, and I know star F changes. And star F is this one here, because it's pointing to there. Okay, so only these two change, because I look at the left-hand side and look what changes. All right, so now I print this out, and I know this has changed and this has changed. If anything else has changed, I've done something wrong. All right? Does that make sense? So this is a quick check. Just look on the left-hand side and go, yep, these things have changed.
Nice. It's looking
Nice.
good. Nice.
Why doesn't A equal 11 in H? Because A equals 11 in I, but 10 in H. Wait. Look, I might actually just get these solutions up so that I don't have to draw it. Save me some time. So we've got H.
Why doesn't A equal 11 in H? I think it is a mistake.
It is?
Hang on, I have to actually look at the original one.
The original one's on my screen.
It doesn't show
What
it.
is that? You're gonna.
Yeah, I think it's just a mistake. I think it's just yeah, accidentally was changed to 11 instead of staying at 10, which is a good spot. Yeah, I think it's just a hiccup for that one. It is just a hiccup for that one.
No. Wait, let me look. Where is it? Function pointer diagram.
So if you look at stat G,
Oops, where did you come from? Go away. A, B, C, D, E, F, G. Oh,
so it goes up to 11 in G, and then in H it goes back to 10.
oh. That is interesting. Okay, yeah, that's a mistake. Is that in the photo as well? It's a photo correction.
10 points to Gryffindor for finding that mistake.
You can blame Ash.
Yep. Blame Ash, everyone. And Josh.
Yeah, I should be able to. Which?
Yeah, no, that's a mistake, man. So that's a good spot.
F equals. Yeah. So I'd use the photo because it stays at 11. And then it changes to 10 later. So use the photo. Because, yeah, now it's 11. It didn't go back to 10 until the following step. So use the photo. This one's wrong. All right. I'm going to give some more questions. Cool. This is a good question. 2009 exam. What's the function? It takes a string as an input and prints out every second character in the string. Function prototype is shown as this. Okay.
Was C taught by Jen at that point?
Yep.
Ah.
I don't know actually. Maybe. So have a go at that question.
Was Jen at uni in 2009? Was he teaching?
I don't know.
He doesn't seem that old. So.
I like the message. I don't check my Facebook. So I want everyone to try this question. You should be able to do this. This is a nice, easy,
Yep.
and take 10 minutes max. Okay. If you do not know how to do it, write everything that you do know
Yep.
to get marks. Okay.
Yeah,
So
like
submit something on the YouTubes or the Hangout.
yeah, or in the exam as well. Anything, there's 10 marks. You don't just go from 0 straight to 10. There's levels in between, and you can get those extra marks, which could be the difference between could be the marks between an A or a B or a C and
So try it.
or God forbid an F, an F and a pass. So just do it.
And don't forget, there is supplementary exams if you, so put in your best, because even if you just fall under, you may get a chance to do a sup. So everyone have a go at that and put your answer in the windows. Or show us what you'd put if you're in an exam right now. And this question came up. I'm going to take a screenshot. Unless someone comes up with an answer, I can copy and paste. Oh.
No.
Question 4. So post your answer.
Stapler?
Well,
I don't know. I'm clicking. Oh. No.
Nope, and you'll never know.
Oh, I know where you live.
Do you?
I do.
What's that announcer?
He lives at. You live at Latrobe. That's where you live.
Yeah, pretty much. Every question. Don't ask if the question's important. All questions are important. We've done 12 weeks of content. We can't tell you which questions are important because there's 12 weeks there of questions. I would. Every question is important. Test your understanding. Try it, please. Write what you'd write if you're in an exam. It's already been 5 minutes. 10 marks. It should take 10 minutes.
What? How did you mute him? No. What the? What the hell? You muted Matt, by the way. That's amazing.
I will kick you if you do it again. I want to see some answers. I want an attempt.
Yeah.
Okay, I want an attempt of what you put on the exam if you were given this question.
Yeah, we're not seeing any. Throw them out, guys. Just, yeah, and attempts. Because then we can see what you don't understand. So we can tell you what you need to change in order to get the correct answer. All right. Please let us some more time. No worries.
Yeah, you've still got 3 minutes. But
Yeah, sure. Yeah. Email it to me, Nick.
One more minute. Okay, everyone needs to start submitting an answer. And I mean everyone. Please.
Yeah.
I want you to
So it's
try.
It's a prerequisite to
Let's see
attempt
what-
the ex-
If you don't know the answer, I want to see what you'd put on the exam. Because there's easy marks here you could easily get just to show that you understand what a function is.
Yeah, we can give you a gauge of how many marks you would have gotten. You know, if you give it an answer and it's not the fully correct answer, we can still kind of give a gauge of how well you would have done for that answer. So you can kind of get a feel for how we'll be marking you.
Less than a minute. 30 seconds. 29, 28, 27, 26. Yeah. So I'm going to quickly go through how I'd go about this. So I'm going to come up with two solutions, just because one with using string length and one not using it. So the first thing I would do is I'd write void print second car star input string. Now here I'm assuming that we've got access to string length. So here what I do is all I do is create a variable I for iteration because I want to go through all the characters. So I want to print out every second one. So what I'm going to do is have a for loop. I equals 1 because I want to start from the first one. Then I'm going to go, well, I is less than or equal to string length. I equals I plus 2. Because I want to look at every second one. And then I just do printf %c input string I. Okay.
Hey, Matt, I sent you in Facebook a screenshot of the question that Nick had.
All right, cool. So that's one way to go about it. Now, if I didn't have string length, we have a bit more problems. And then we can go through it using pointers as well, because it's the pointers. And I might do it with pointers as well. What I'm going to do is I'm going to say
while input star input string not equal to 0. Then I'm going to go input string plus plus. Then I'm going to go if star input string is equal to 0. So 0 is the same as null terminating character, and it's break. Else, I am going to printf %c, and I'm going to print out my input string. And then I'm just going to go input string plus plus. And this is a little bit more elegant solution, but if you've got string length, the problem is very simple. If you want to use pointers, you can do it this way. So I think you should understand how this works. So if my string is hello Jen, then this is 0, 1, 2, 3, 4, 5, 6, 7, 8. And this is 0. The reason I use 1, well, I'll show you in 2 seconds. So we want to print out every second letter, so E, L, Z, E. I don't know how long the string is. So I start at 1 because the first thing I want to print out is this E. Okay, so I print that out because it's input string 1 and it prints out an E. Then I go back up in my loop and add 2, so now I'm on 3. And then I print out L. Now this is 8 long.
Matt,
Oh, yes.
should we dereference the string before printing?
What's this doing?
Oh, that's why we are not using star, right?
Yeah.
Yeah.
Remember, this is the same thing as writing. Yeah. They're the same statement. Okay. The star's implied when you use them kind of brackets. Okay. And then we go back up. We add another 2, so we get the Z. Write Z. Then we go back up. We add 2 again. We get a 7, which is an E. And then we go back up and we have a 9. 9 is less than, is greater than, and not equal to string length. And this should actually be less than. I don't know why I put that there. And then you're done. Now, this solution, it may be able to improve it, but I'm just using pointer arithmetic instead. I think it's a little nicer. So we're currently pointing here. Is this 0? Is this an null terminating character? No. So we increment to this first one. Is that a 0? If it is, then we break. If it's not, then we print it out. Then we increment. Is that a 0? No. So we keep going. Increment, get the second character. Is that a 0? No. Then we print out the second one. And so that's getting every second one while still checking the null terminating. Okay. There's lots of solutions for problems like this. There's a couple of other ways to go about it, but I think they're nice.
So, Anderson. Is it a horrible question? Oh. Okay. This is one of those ugly questions. Blame Josh. But it is actually a good question.
What one's this? Is this the one Nick sent you?
It is a good question. Okay. So this goes back to very early on. I don't want to print the first, I want to print the second. Sorry.
What?
Okay. Okay. Both Bo and whoever Null is. We don't
No. So Nell was asking like why we started I1, and I said it's because we want to start printing this. Yeah.
Okay. 0 is first. 1 is second. Be very careful of this, okay? When we talk in terms of first, second, third, fourth, we're referring to 0 is the first, 1 is the second, 2 is the third, and 4. 3 is the fourth.
Because an array starts at zeros, and same with strings. We consider the first character in a string as the 0th character. The second character is at the first position, and so in that question, we wanted to print out every second character. So the second character is at position 1, then the fourth character is at position 3.
Yeah, and I made a mistake.
And so
There should be input string inside these brackets. And not dot. We're not using Java.
Oh man, if anyone does dot, what is it? Dot length.
Dot. Yeah,
it's just dot length. Yeah.
Yeah, he got your email. He passed it on. It's on the screen now.
Yeah, Nick, it's Matt's in the question at the moment. We just started, so we haven't gone into it.
Is he up to? Can you see it?
All right, cool.
All right. So this goes back to the time when we looked. Please zoom in.
It was, yeah.
I can't zoom in because then pen goes funny. I can do is do that.
What?
It just makes it look ugly, but all right. So this has to do with something we did very, very early on, and this is the input buffer. So dun 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 dun. So we have on our input buffer 7, comma, space 1.995. Wow, I did that exactly how many I finished. Oh,
that is actually pretty amazing.
Okay, so we create 2 variables, A and B, and C, which is 3 variables. This one's an int, this one's an int, and this one's a float. Okay, so we've done that, we've done that. So now we're looking at this scanf function. So we got %d
comma, %d, %f. So what this is looking for, it will look through the input buffer and look for this first %d. So it'll look through this and it'll grab the 7 as because a comma follows, and a comma is not part of the format specifier for a decimal int. So it'll grab the 7. It will then store the 7 into our first argument that follows, which is our A. So A has a 7 in it. B, then it will look for a comma and it'll find that comma. Then there'll be some white space. So it'll capture that. It's just scanning and seeing if they match. It's doing some pattern matching. So they're gone from the buffer. That's also gone from the buffer. So the buffer's up to here. So that's done, that's done. And now it'll look for this %d. So it will grab the 1 because there's no dots in an int. So B now holds a 1, and that's off the buffer. So the buffer has now got 0.995. So C will look for a float. So it'll see a point and then a 995. So now 0.995 in our float. Then we have some fun stuff. We have A equals A mod 8 minus B. We have equals 7 mod 8 minus B. Now, the mod operator is just the remainder. So if we have 7 divided by 8, the remainder is 7. Yeah? Yeah. So this is the same as saying 7. And B is 1, so we have 6. So this should be 6. We have C times equals B, and then we can rewrite that as C times B. So we have 0.995 times 1, which is exactly the same thing. So nothing changes. And so our result will be result good D, which is A. So we get 6, comma, space, dot 4. So we have 0.9950. I hope that's right. It's a bit of an ugly question.
Does it make sense, Nick? Or to anyone else?
Does it make sense to you, Jabbo?
Only sometimes. Depends on what mood I'm in. Yeah. I sent you in Messenger another question that someone had.
From where?
Another quiz question. Magic.
Didn't we already cover this one?
Yeah, it looks like one, but I don't think it's the same.
No, it's not. I did this one last night for someone else. Who sent this?
Salim.
This is a really good question. What's up?
That res.
Yeah, it's because I copied it from there. I can't really do much about that, unfortunately. I'll make it worse.
I think you get the ratio now. It's off as well.
What?
The ratio is off as now, like as well.
Yeah, I know. Okay, so this is a really nice question. Nice easy one to start off with. All right. So this one here, I can see there's a lot of pointers going along, so I'm going to use pointer diagrams because it'll make it easier. I know there's two functions, so I'm going to draw the two functions. So I'm going to start with main, that thing. So we've got main. I've then got an array. So I've got R, just pointing to the start, and I've got 4, 2, 6, 1, and 7. I've then got an X, which is int. I've got 0 in there. Oh, what did I just do? Then I go to my other function, which is func, because I'm calling it here. I now create these 3 variables first. So I've got p, which is pointer. I've got n, and then I've got r, which is also a pointer. They're all the same type, so I'm not going to worry about types. Everything's an int, so it doesn't really matter. Then I've got r, pointer p, so this is going to point the same place r points. I've then got n, which is 5, and I've got, because that just passes there, and then I've got the address of x. So this would just go here. Then I've got I. It takes the value that p is pointing at, so it's got 4 in it. And then I have q, which is a pointer, and it takes the value of p. So it also points at 4. Then I have what r points at is going to be 0. It already is 0, so I can ignore that. Then I have while p is less than q plus n. So p is here, so I can think of it as being 0, and I have q plus n. So I have this address plus 5. So it's talking about here. Okay, that's 5. 0, 1, 2, 3, 4, 5. I can treat this as a number even though it's an address. So you're really saying address 0, address 5. Remember, this would actually be times by 4 because they're ints. So this pointer here is less than this plus 5. So, and as Bo said, you can look at it visually and you can see that's true. Now, is star p less than I? So star p is 4. Is 4 less than 4? No. So just increment the pointer. So now p points to
that
2.
boy.
We go back up. P less than q plus n. So q is still pointing at this first one, plus 5. So we're talking about here. This is less than this. Cool. So we keep going. Is star p less than I? Is 2 less than 4? Yes. So now we have star r equals p minus q. Q. So p minus q is, where are we? P is here. So we can basically treat it as 1 minus 0. Okay? Because we're taking the addresses. So even if this was 1001 and this was, it doesn't really matter what the address is because we're just doing a subtraction. So this minus this is going to be 1. This equals 1. And same thing if we had, yeah. So star r equals 1. So we get a 1 here. Because we're talking about pointer difference. And then we have I equals whatever p was pointing at. P is pointing at 2. So I
becomes 2. Whoop. Then we increment the pointer. So now this points at a 6. Check. Is P less than Q plus N? Yes, Q plus N is here. This is here. It's still less than it. Is star P less than I? Is 6 less than 2? No, so we keep going. Now it'll point to here. This is still less than here. Okay, we can see visually that this is still less than it. Is 1 less than 2? Is 1 less than 4, sorry. 1 less than 2, sorry. Yes. Okay, because remember I is 2 and dereference P is 1. So we've got star R equals P minus Q. So P minus Q, so 0, 1, 2, 3. So we've got 3 minus 0. So this would be 3. So this is going to be 3. And then we set I to equal what P is pointing at. So P is pointing at a 1. So now I equals a 1. Then we move this pointer again. This location is still less than this location here. So we now have, where are we? Is 7 less than 1? I hope not. So we increment the pointer again. It's now pointing at this black hole, which is after the array. That isn't less than that. They're both equal. So then we end this function and return, and all of this stuff's gone, and we print out. Okay.
Yep.
That would probably be my working for that question in an exam. And that's why I did it quickly, just to show you. You can do it fairly rough. You don't have to write it out really neatly when you're just trying to get the output. If you're doing the box and pointer, I'd do it a little bit neater. But for working out,
Anyone else got any questions they want answered? Send them to my email or just post them in chat.
I
think we had one from
Bo's email address. If you can put them in the chat, it's better.
Yeah.
Oh,
Got the one from Latrobe Hookups. Just a couple up.
Does it correlate with the exam? What? Oh.
No, the one after, like, I've got it. Oh, yeah.
Wait. Did he print it twice?
I think so. It's slightly different. It's just I instead of C. I think the second one is like fixing it.
I think was this. No, this was the attempt. This was the attempt of the question I gave him.
Oh, never mind. Okay. I got you. Yep.
Do a live stream an hour before the exam and give the answers. Love clinical cup, bro. Nah, don't think so.
Well, I'll do a live stream an hour after the exam and give you the answers.
I don't even think you've got the exam, do you?
No, I don't. It's super secret.
It is super secret.
Who's seen it? Has Josh seen it?
I've seen it. Josh just glanced at it. He hasn't got a copy of it though.
Yeah. Oof.
Actually, no. He might have an old version.
So, Josh lives at uni, literally everyone, so if you can find him, you can rack that exam paper.
So how many marks was that attempt worth? I don't know. Exactly. So I'm not going to mark it, but that's an attempt.
Yeah.
And
So
you included an if statement, you included the print. It is wrong. You also you should have included the function. That's an easy bit of marks, putting the function in, if you're told to put a function. And same goes with your whole program. First thing I would do is include standard IO and main, like easy marks. Yeah, so that question, this question is actually a really good question. I would try and know how that works for the
all right.
exam.
I got a question coming to your message, Matt.
On Messenger. Why are they emailing?
Yep. Because it's hard to post them in chat, apparently. I think it is, because like it's.
You can't put images. Well, type.
There you go. That looks blocked. No, that's fine.
I've been through this question like 10 times. Oh, wait. I think I was meant to go.
What?
I've been through this question as well. This one's... Who sent this one?
Darius.
Who?
Darius Dowan. In YouTube.
Okay.
We already know the answer.
So, if the answer's given on the exam, then I'd go with that one. That was easy. Yeah, so if the answer's already given, it makes it really easy.
No, we're just tricking you. But don't trust them. Don't trust Matt. Never do it.
Yeah, don't trust everything you read. As you know, there's lots of mistakes. It's easy to make mistakes to see, and that's why you should show your working, because it is easy to make mistakes. And same goes with maths as well.
Yeah, it's like exactly. It's like in a maths exam. If you if you do the working and then you just have like one slight error somewhere, in the middle or towards the end that gives you the wrong answer, but everything else is correct, they'll still give you mostly full marks. Like you can still get 80%, 70% of the marks.
Give me a sec. I just want to check something. Where the hell did that go? I want to check something in the 2011 exam, because someone was asking a question about that. I'm pretty sure we did that last time. So I just want to check if it's the same question. 2011. What is this?
Are you keen for the new Rogue one?
Yep. Yeah. Question 2 we did in the last help session, so refer to that.
Yep. Yeah. So
the
help sessions, they're on your channel, aren't they?
No, they're on the LMS. They're private.
Yeah.
Everything's
so you can yeah. So if you want to look at the previous live stream, so last night's one, you can go to to LMS and look at that.
Okay. So the first thing I would do if I got this question, I'd go, okay, this is defiance. So num words is 4. So I go through this whole thing, look for num words, and just cross it out and go 4. Easy. I then look through my code and I see if def verbose. Is verbose defined? No. Stuff that. Get rid of that. It's not part of it. It's not defined, so I can just ignore that.
Actually, there's a question before that we missed. I think I saw a person ask, "What's the difference between if and fdef?" If def.
That was hard week 12. But yeah, I'll leave that up to the audience to answer, and then the best answer win a prize.
Yeah.
All right. So that'd be the first thing I would do. Now, this happens at pre-compile time. So that's one of the main things about the difference between if-def and ifs. It's also finding if defines. The question was if it was defined. So if it was defined, verbose. If it was defined, well, it's defined, so this is included. So I can ignore these two lines and just include it as part of my code. If it's not defined, I just get rid of all of this. That's the two cases. There's not much more to it. Okay, does that make sense? Cool. All right, so here we have a character array, z, character. Then we have int I should be not written like that. It should be written on the top, but blame Josh. Then we have car input, which is length 4. So this is input. I'm just writing this shorthand. And then we scanf input for %3s. So we're only getting 3 characters. So we get the word FAT. We're storing it as a string, so it'll add the null terminating character. And then we compare. Is input, so we do a string compare. Now, string compare will return one of 3 things. Well, we'll return more than 1 of 3 things, but if, so I'm just going to put A and B there. If A is less than B, how the fuck do you spell it?
Wait, what? Lexico? No, it's LEXI, Lexico, yeah. And then do co, and then graphically.
Graphic.
I'm fairly certain.
There we go. Yeah.
Good enough.
Whatever. Is less than B, lexicographically, meaning, we'll fuck this word off.
Let's call it if it's Lexi. Oh, if it's. Here we go. I now know your weakness.
Okay. If A is less than
You're muted, Matt. Matt.
How dare you mute me?
I did, but the guy did.
I know.
That's so funny.
Next person to mute me, I'm leaving. So if A is less than B, would it appear before? Would it appear before in the dictionary? So if I have something, so if A is less than B, a string like A, B, C, and then I have, let's make it a little bit more interesting than that. Let's say A, D, E. A would appear before A, D, E in the dictionary. So if this is the case, then it will return a number smaller than 0. If A is greater than B in terms of the dictionary, then it will return a number greater than 0. And if they're the same, then it will return 0. Okay? Does that make sense? So here we're saying string compare. We have fat and ZZZ. And we're saying, is it less than 0? So who says yep? Who says no? Who says something? So yes, it would be less than 0 because fat is less than ZZZZ in terms of the dictionary. So we go into here and we do a copy. Okay, so input gets copied into S. So now S has fat. Okay. We then go back up. We add 1. 1 is less than 4, so we continue. We create this input again, even though we don't need to. And then we grab the next 3 from our set. Now, it will ignore the white space, and it'll grab dog. Okay, so now we compare dog with fat. Is dog less than fat? I'll leave it to you to answer. Of course. Cool. So it will return a number less than 0. So we go into this thing and we copy. So now S has dog. Okay. So now we go back up. We add 1. So now it's 2. We create input again for no reason. And then we grab the next word, which is cat. Now, is cat less than dog? Is cat less than dog?
Oh,
yes,
damn.
of course. Of course they are, because dogs are better. So now this would have cat in it. Now, we go back up. This equals 3. 3 is less than 4. Is Pip less than cat? No. So we go back up. A equals 4. Is 4 less than 4? No. So we print out cat. Draw. Cool.
Matt, in
Sure.
storage classes and scope and linkage important?
Scope is important. Definitely. Let me have a look. What was the other thing you asked?
Storage classes, linkage.
Storage classes, definitely. That's the first thing. We've covered that a couple of times already. So just knowing how to store, like we did the question about the structs, we did the question about car, we did the question about short. So you should know all about the storage classes. And then there's scope, you should know. Oh, sorry. Linkage, you need to understand not so much because we're not dealing with header files in the exam. So not really.
Yeah.
Not even the library files, right?
Our library files will be a part
Yeah,
of the
yeah,
exam.
yeah, definitely, but not your own header files.
Yeah.
Why?
Not your own header files. So you should understand linkage in terms of the ones that are there, but it just
Yeah, but we are not going to deal with two different files and everything like that, right?
no.
No.
All right, thank you.
All right.
What are the questions you guys got? Throw it at us.
Throw it up, bro. Throw it both space,
Huh?
make him bleed. Throw it up both space, make him bleed.
They've been pretty
All
mean,
right.
but I'd still take it. I'll still answer it.
Let me get rid of some of this stuff. Create a new one, and let's throw the final question up.
It's a lot of variables, man. Swift. You got C or B.
Yeah, I know. What do I want to do with this one? That's B. I want. Yeah. Yeah, that'll work. We'll do that. Okay.
What a question. Imagine if you saw that code in real life. Like you just opened up a file and you had that.
Cream of the variable names. There you go. Give us a print. No, just left.
Yeah. No, yeah. Good.
Okay, try this question. It's actually not that hard. It's tame. But here we go. If you draw the box play diagram, you get like pretty quickly.
Yeah, the values aren't changing, so I don't think a box and pointer diagram is even needed. You just kind of
Yeah. Yeah,
you still draw it, but you just do the variable name and the value underneath.
Well, there's only 2 values in the whole thing.
Yeah, but like then you write like another variable as like that's a pointer, and you just point it to the value.
Exactly. Just 2 box and pointer diagrams.
Yeah, but without the type and without the box around.
Yeah, well, you don't have the type. There's only really 3. Well, how many combinations? 4, 4, 4, 6, 6, 4, 6, 6.
So it's like a multiple choice question. You got a 1 in 4 chance.
Yeah.
Which is good odds.
I haven't actually tried it, so I don't know the answer. Barry's gonna try it, so I think so.
I went through it. I got an answer. I hope they got it right. In fact, you can just quickly look at it. You can see straight away what it has to be. Yeah, there's a simple clue to this, which I'll tell when we're done, which you can tell straight away what the answer has to be.
I've got G. F is... Oh, yeah. Okay, yeah, it's really easy.
So I see some answers. I'll give you guys 10 more seconds just to pop out an answer, then we'll go through it. Just pop something out what you think it is. Alrighty, so the answer is 4, 4, and we could go through all the diagrams and stuff to figure it out, or you could just look straight up at the top. When we assign to Z, we get the memory address of X, yeah? And then you can look nowhere else in the code do we get the memory address of Y. We never ever get the memory address of Y. So you can tell that we never actually use pointers to access Y. So when we print out F and G, they can't actually be a value which it can't be the value of Y. It has to be 4. They both have to be 4. So it's 4, 4. Otherwise, you can just do like a box and pointer diagram, and you should also pretty quickly get to the answer as well. But hopefully that makes sense, yeah, because you can see in the code, you never get Y's memory address. So if you're using pointers to get the value for F and G, those pointers will never point to Y. So the only other value is 4, so they both have to be 4.
So you can also look at it like this. If I link everything up, nothing ever connects to Y.
Yeah.
Okay. So as Bo said, the X relates to this X, the Z relates here, the A relates here, B relates here, the C relates here, D relates back here, C relates here. D and E are never used. They're just, you can just disregard them. So it has to be X for both of them. You have to get 4 and 4.
Any other questions? Yeah. Also, if that was like, if you can't do it, this is just an example. But if you can't do a question, and in particular, if you couldn't do this question, like Matt pointed out at the start, there's like 4 answers it can be. Yeah, and you can kind of deduce that just by looking at, you're putting out 2 values, f and g. Well, what values can they be? And then you look at f and g, and they're both integers. So you go, well, they have to either be 4 or 6. Yeah, so you can either have like a guess. With this one, you should be able to figure it out, but there might be other questions where you can kind of deduce in general what the answer might be. You don't know how to figure out exactly which one it is, but you can still kind of have like a bit of a guess. So definitely go for the guess, like an educated guess. That's if you absolutely can't figure it out.
I have a question. For getting out the value of g, how do you derefer first b and then the value again?
Well,
So-
this here is the same as saying this here.
Okay.
Because you're dereferencing B and then you're dereferencing it again. It's the same here as dereferencing it. That's
Yeah,
just
so,
what makes it confusing.
so B stores the memory address of A, which stores the memory address of X. So when you
just put
dereference
A there.
B twice, it gets to the value that's stored in X.
Mm-hmm. Thanks.
Now do we do function points?
Yeah, that's actually a good point. We didn't do those. I don't think we did them. No, when I did see, we didn't do them either. They're useful though.
Yes. Yes, they are. What am I going to do?
I don't think we did any questions on structs.
What, now?
Well, never, but like over the whole live stream, we haven't done a question on a struct.
Hit one.
Well, we did one, and we asked. But that question was what? How should we store 3 values?
Well, not everyone knows how to use structs though. Maybe.
Yeah. That's true. We haven't got any questions on them. So.
Everyone's expert
Does anyone have
at
any?
structs.
Does anyone have any struct questions? What are you drawing?
What was I saying?
Any question, guys? Come on, hit us up.
I should get them to create a struct for the limits of an integral, the variable, what it's in reference to, and yeah, the constants.
God damn, you're a mean person.
Oh, they're not maths tomorrow.
Yeah, true. It's like knocking out 2 in 1, eh? You can
Yes,
study
yeah,
at math
very
and program.
So the question was in the box and point diagrams. As I've said, yes, you'll have to redraw them each time. That's why you need to be quick at it. However, it won't be as long as the lab 12. Lab 12 one.
Whoa.
Go.
Yes. What, man?
It is a lot of boxes. But this is why I said you need to get practice just drawing them and drawing them quickly.
What the hell? How'd you find this?
Stock space.
Huh?
Stock space.
No way. They got a lot of signatures. I wonder what's so bad about it.
All right.
I have a friend who's doing law.
Shout out to those who have maths at 9 a.m. and are still up. Well, yeah.
Do you have maths at
That's all.
9, Josh?
That's all right, Ela. Thank you very much for coming, and thank you very much for all your attendance during all the live streams.
Yeah, good night, Ela. Thank you.
Attended pretty much all of them, I'm sure.
No, bro. I reckon there should be a minimum. Like exams should be after at least 11 a.m. I
6
reckon
a.m.
6 a.m. You're a monster, man.
I would fucking kill exams if they started at like 6 a.m. I'd love that.
No, you gotta have that. You gotta have that last minute cram. 9 a.m. doesn't give you the time to cram.
Guys, are you going to cover anything important
No,
after
we're probably
this?
going to finish very soon. No, I think everyone's leaving. Unless there's any last minute questions, that's about it. Good luck with your exam. Good luck with your maths exam.
Yeah.
You guys should do
Good luck,
well.
everyone.
If you've got any last minute emails, if you get a bunch of them, I'll do a quick session at 1 o'clock. I'll be around the uni. If you email me, I can tell you where my office is. I'm not going to put it on here. And you can come find me. Let me just check if I've got any meetings at that time. And Bo, are you around tomorrow?
Yeah, I'm around. So that talk ends about 1:30. So, but what? Yeah, because what time does the exam start? It starts at 2, doesn't it? So hang on, I don't.
They finished their first exam at 1:15. I think.
Wait, the math one at 1:15.
9.
No, it'd be 12:15.
Oh, 12.
Hang on.
All right. They can come to the talk. Yeah. Me and Bo will be in the room to help you with questions.
Yeah, so
if you want to find
Ash should be there as well.
Yeah, he doesn't want to come to the talk. So send me an email if you want to find my office, and we'll all be there.
Yep.
At about 1. Okay.
Yep. So
for the exam.
Yeah. Otherwise, good luck, guys. I just got up here. So the exam is. Hang on, where'd it go?
It's the exam hard.
It's at West Lecture Theatre. Where?
It's easier than the assignments.
Yeah.
Just my advice is with this exam, pace yourself. With programming exams, you can easily get stuck on a question over and over and over again. Try and keep your eye on the clock.
Yeah. Every mark counts, so every mark you can squeeze out counts, and so first and foremost, attempting every question will give you the maximum kind of spread.
It's only 2 hours, so you do need to pace yourself to get through it.
Getting 100% on the first half of the exam is not, isn't as good as getting 75% across the whole exam. So, you want to attempt every question, or at least try to, as well as you can.
How much is the weightage for the extra question for 5 PS?
It's
30. Is it?
It's whatever the extra. It's worth the same amount of time, so it's 30. Let me grab the exam. exam.
Yeah, it says half an hour extra, so that's 30 marks extra.
30, so the last question's worth 30 marks. How many questions aside from the multi? So we already went through that earlier, but I can tell you exactly. Looking at multi-screens.
Yeah, man, I got my first multi-screen the other day. I got a vertical one.
Yeah.
It's really nice.
Oh, it's me. It's me that I can
Just
open. All right. So you have multi-choice. Then you have output questions. And you have box and pointer. What are you laughing at?
Don't. I'm laughing at my own joke.
You
Not a
have
very good one.
errors. Then you have flow diagram. And then you have the full program. You have 120 marks. This is worth 30. These are, I think, similar. I don't have the marks for that. This isn't worth very much, and these are pretty much the same. So pretty much, I think these are something around 20-ish, and that's the leftover, and that's not worth very much. Something like that. But they're the questions. This is fairly large, the output. And that's where you can waste a lot of time. So don't waste time there. You may want to do the order that I'd probably go about it is do the box and pointer, the flow diagram first, and then I would do the output in the full program, because these you can smash out fairly quickly. No, the flow diagram is wait, the full program. No, it's not. It's not similar to the lab class. It's similar to lab 10, as I went through last time. So just once again, lab 10. Oh, all right. It'll be something like this. It's going to be shorter than this, so maybe something like maybe, and it'll just tell you what it should do, and then from there you need to write the code. Okay. So no, it's not going to be exactly like the labs. It's going to be a problem statement, and it shows that you can solve a problem. Set of tools. Very hardest. It is a good exam to test your skill at problem solving, and even if you're not doing much coding, this skill is really important. also you're all going to do more coding anyway, so you can't escape that. Can't escape.
Can't escape.
Unless you quit.
Why would you want to though? Coding is life. Coding is love.
True that. True that. It really does open up so many avenues in knowing how to code. Even stuff you didn't think about. Like I was talking to Bo earlier today about making games and stuff. But also solving problems
Yeah.
in physics, mechanics, soils, whatever. It makes a huge difference.
Yeah. I mean, if you're good at problem solving, you can use problem solving you can apply it to anything. I mean, you can apply it to learning even, you can look at learning a new concept or learning, like a new programming language as a problem. And if you can figure out how to solve that problem efficiently or, learn how to, know how to learn that new skill efficiently, then it's really good. Yeah.
How long does it take to be an adequate programmer? How long is this piece of string?
Yeah, that's a really tough question.
It's a tough question, and also there's different types of programmers. Like you could ask for a code monkey, which is just someone that you tell them how to do something and they do it. And then you've got people that can problem solve but don't know all the technicalities of all the languages. And then there is so many different avenues of programming.
Yes,
and different fields.
That's the biggest thing.
And then you've got the language side of things. So the language itself is like learning another language. It's very similar to mathematics in terms of the language, especially when you get onto the mathematics. But just understanding languages and being able to understand it naturally, code and look at it like it's English. But yeah, there's no real answer. How long have we been programming for? We started yesterday, actually.
Yeah, man. I've probably been doing it for about 6 years, but properly for the past maybe 4. 6 was just kind of dabbling at the end of high school and stuff, and then the last 4 has been properly uni and all that. But
too long.
Yeah.
I'm gonna answer that. So you actually start. So you could actually extend that even further. You could actually say you started programming really the logic side of things. It starts when you start learning English, really.
Yeah. Well, that's the thing with programming. People ask what makes it how do you become a good programmer? Yeah, and you're not a good programmer if you know a language. Just because you know C really well doesn't make you a good programmer. You could be the actual textbook in your head, for C, and you still wouldn't be a good programmer. It's because C is just a tool. Yeah,
it's the difference.
It's a tool. Yeah, it's a tool to solve problems, So, and if you can't use it to solve problems, then it's useless. So, really, the best skill you can have is how to solve problems, and and computers are really good at solving problems if you know how to use them right. And that's when you're a good programmer. A good programmer can make the computer solve problems really well.
What languages would we recommend after C? So that depends on what you want to do. If you're doing engineering-based stuff. If you're doing electronics, definitely assembler. Or to understand what the hardware's doing. If you're just wanting to dabble, I would recommend Python or C++ or Java. If you've got something specific, then there's lots of languages and you have to have a look out. But if you just want to play around with it, I'd just go look at it next. MATLAB as well. MATLAB Definitely MATLAB if you're doing engineering.
Yeah, if you want to see the other side, because if you're doing engineering, you'll see very low level code. C is kind of high level, but it's not really. And it's definitely worth checking out Java or something because it gives you a kind of new experience. Yeah, Java brings into the world of object-oriented programming, which is very different from the way you guys have been using your C programs.
MATLAB is based on C. It appears easy when you start off because you've got a lot of functions, but when you need to start working on creating some of them functions yourself, it can get, especially when you've got matrices in the sizes of millions of dimensions. How many languages do you guys know?
No. I probably only know I know maybe 3 properly. I know Java, C, and JavaScript really well. And then I've dabbled in C++. So I could write programs in C++, but I'd have to be looking up stuff all the time. And
English?
Yeah, English. That's another one.
I'd say I'm pretty confident. Maybe 10 or so, maybe more. I don't know.
Yeah, when you learn a few languages, you realize they're all very similar. At least when you learn a few different paradigms, if you do some object-oriented stuff and all that, it becomes very easy to pick it up.
The big differences will be the big differences will be if you go to assembler or something like that. If you go to hardware languages, so if you go to something like VHDL, something like that, that gets very different. That's a really cool language.
There's also some really cool languages. If you guys really get into computer science stuff, there's a language called Lisp, another called Scala, or Prolog. They're really different. They're very, very different languages.
Yeah, and as Bo was saying, there's languages we're confident with, but there's also languages we've played around with.
I'm
probably at least 50 languages.
Yeah, I reckon I could use 10. I could use 3. I reckon very confidently. I could go to an interview and kind of interview on them. But then the others, I couldn't do that. They could ask, but I could still use them. So C++ or C# and stuff. I could look up a guide online or something and understand what's going on. But that's just because you realize programming languages are very similar to each other. They have a lot of things that's if you go learn Java, you'll notice all the structure and the syntax and stuff is C.
Broken.
Yeah, and also broken. Java's it's this thing you love, but it ruins you at the same time. It's so easy to use, but it's also so terrible. It's a really bad language, but it's also really good.
That's not an original idea of Elon Musk. There's actually some really good books on it about simulation, and that's where the whole Matrix movie came from, things like that.
I watched a video yesterday actually on this where there was a guy in 1970. He asked a bunch of physicists. So this video is from 1970. He asked a bunch of physicists this question. They all laughed, and it was just kind of interesting.
It's been around for ages. There was some really good books written. There's some really old books about it, but especially when computers in the 70s and 80s, there was a lot of books on this kind of stuff.
Yeah.
Started coming about.
Yeah.
I'm not going to offer an opinion.
Yeah. Yeah. If you want to get good at programming, think of a project you want to work on. Instead of just reading from a book and doing the practice questions, or like even like doing a subject, like the subject, the stuff that we've done semester, it's been very good because we've done in the labs a lot of problem solving and stuff, but we haven't done like a big project. So
that applies for anything. So if you're doing civil engineering and you want to learn about bridges, fucking go build one.
It also helps you to get
if you're doing electronics, build it. Like, don't just learn the theory, build it and play with it. It's the best.
Yeah.
And it applies, anything really. Just doing it, and if you come up with the problem yourself, it means something more. And so
so come up with your dream application or dream thing. You want to create an arm, like a robot arm that does stuff. Then start working towards it. It might not be feasible, but if you're still working on it, you'll learn a ton working on it. And not only that, there's a lot of projects. Like, you don't have to come up with your own project. There's a lot of open source stuff, so you can go online and look for communities they're all building software together, and you can join in and help them, which is really useful as well to practice your skills. USC election rumble. Yeah, what time is it in the US? Have they started voting? What time?
I don't know. Good question.
Time, New York. It's 9 a.m. in New York. So yes, they've probably started voting.
It was funny. Anyways, we probably should kill this stream. If you want to continue chatting, you can join the Hangout because they got to kill the stream. The Hangout link's there if you want to keep chatting, guys.
Wait, where's the link?
The link's
post it back in chat.
Yeah. If you want to keep chatting, you have to join here because they got to kill the stream. He's going to kill my network otherwise.
You gotta what?
All right.
Did you kill it?
Thank you very much. Thanks.
Yeah, thanks, guys.
Attending.
And good luck.
Good luck.
God bless, and God bless Australia.